The Big Bang did not bang. What we call the beginning never truly began. The moment of creation, that singular point from which all reality supposedly emerged, was neither a moment nor a point, nor perhaps even a creation. The universe didn't explode into being. It didn't suddenly appear. What we've been telling ourselves for decades, that perfect cosmic origin story, is fundamentally wrong. You've seen the imagery countless times: a brilliant flash, an expanding sphere of light and energy, matter bursting forth from nothingness. It's comforting, cinematic, comprehensible. It gives us a starting point, a first page in the cosmic story. But what if I told you the universe has no first page? What if the book of existence has no beginning and no end, just an infinite middle that folds back on itself in ways our minds were never designed to grasp? Close your eyes. Picture absolute nothingness. Can you? Look closer at that darkness behind your eyelids. There are still thoughts, still awareness, still something. True nothingness. The absence of space, time, laws, mathematics, possibility itself is fundamentally unimaginable to the human mind. And yet, that's what we claim preceded everything. We comfort ourselves with stories of cosmic genesis that make intuitive sense, but the edge of reality cares nothing for our intuition. If you could rewind time, truly rewind it, what would you see? Would you witness the universe contracting? Galaxies rushing toward each other, stars imploding, matter condensing into an infinitesimal point? Or would you see something far stranger, something that defies not just explanation, but the very concept of explanation itself? What if, as you approached that supposed beginning, time itself became meaningless, space ceased to exist in any recognizable form, and the very laws of physics that enable us to ask these questions dissolved into quantum uncertainty? The truth is, we don't know. And it's possible we can't know. Not because we haven't built powerful enough telescopes or particle accelerators, but because our minds, evolved on a tiny planet to understand medium-sized objects moving at medium speeds, may be fundamentally incapable of comprehending the true nature of reality's edge. But tonight, we're going to try anyway, and I'm going to take you on a journey to the boundaries of existence. Not just to the edge of the observable universe, but to the edge of reality itself. We'll venture into places where space and time fray and tear, where the reliable laws of physics break down, where existence itself becomes questionable. I can't promise you'll understand everything you see. I can't even promise that understanding is possible. But I can promise you'll never look at reality the same way again. Because the universe is stranger than we suppose. It may be stranger than we can suppose. The story begins, or perhaps continues, with light. Ancient light streaming toward us from every direction, carrying whispered messages from the cosmos. For decades, we've captured this light, analyzed it, and used it to piece together a picture of our cosmic history. We call it the cosmic microwave background radiation, the afterglow of the Big Bang, the oldest light in the universe. It shows us a universe that was once incredibly hot, incredibly dense, and remarkably uniform. But it doesn't show us the beginning. It only shows us what happened after. After what? That's where things get interesting. When you look up at the night sky, you're not seeing the universe as it is. You're seeing it as it was. The light from the nearest star took over 4 years to reach your eyes. The light from the nearest galaxy took over 2 million years. And the cosmic microwave background radiation, that ancient light that bathes us from all directions, took approximately 13.8 billion years. We're looking at ghosts, echoes from the deep past. But no matter how far we look, no matter how sensitive our instruments become, we can never directly observe the moment of creation itself. There's a wall of light that blocks our view, a moment when the universe was so dense, so hot, that light couldn't travel freely. We call it the surface of last scattering. It's like a cosmic horizon, beyond which we cannot see, at least not with conventional telescopes. What lies beyond that horizon? What came before that moment? Our mathematics suggests a singularity, a point of infinite density and zero volume, where all equations break down, where reality as we understand it ceases to exist. But is that what actually happened? Or is it simply the point at which our understanding fails? Consider this unsettling possibility. What if the Big Bang wasn't the beginning at all? What if it was merely a transition? One of many in an eternal, perhaps infinite cycle of expansion and contraction. What if our universe is just one bubble in a vast, seething foam of multiverses, each with its own laws, its own histories, its own possibilities? What if what we call reality is merely one manifestation of something far larger, far stranger, and far more fundamental? You might be thinking these are merely philosophical questions, the kind of late-night speculations that dissolve in the harsh light of scientific day. But you'd be wrong. These questions now stand at the frontier of modern physics, cosmology, and mathematics. The edge of reality isn't just some poetic concept. It's a place where our most brilliant minds are working to unravel the deepest mysteries of existence. And to understand why, we need to confront an uncomfortable truth. Our current model of the universe, as successful as it's been, is fundamentally incomplete. The standard model of particle physics, the crowning achievement of modern science, can explain 3 of the 4 fundamental forces with astonishing precision. It predicted the existence of the Higgs boson decades before we found it. It accounts for every particle we've ever observed in our most powerful accelerators. But it cannot explain gravity. It cannot tell us why the universe is accelerating in its expansion rather than slowing down. It cannot resolve the conflict between quantum mechanics and general relativity, the rules that govern the very small and the very large. At the center of this conflict lies a profound paradox. General relativity, Einstein's masterpiece, tells us that space and time are dynamic, that massive objects warp the fabric of space-time like weights on a trampoline. It's a deterministic theory, where the future follows inevitably from the past according to precise mathematical laws. Quantum mechanics, on the other hand, tells us that at the smallest scales, reality is fundamentally probabilistic. Particles exist not in definite states, but as clouds of possibility, collapsing into concrete reality only when observed. Both theories have been tested thousands of times. Both have passed every experimental challenge with flying colors. And yet, they cannot both be completely right, because they contradict each other at the most fundamental level. Where does this contradiction become unavoidable? At the edge of reality, in the hearts of black holes, in the quantum foam of space-time, and in the first fraction of a second after the Big Bang, or before it, or instead of it. Imagine rewinding the cosmic film, watching galaxies rush toward each other, stars imploding rather than exploding, all matter and energy condensing into an ever hotter, ever denser state. According to general relativity, this rewind would eventually reach a singularity, a point where density becomes infinite, volume becomes zero, and the laws of physics break down entirely. But quantum mechanics doesn't allow for perfect singularities. The uncertainty principle, one of its bedrock foundations, forbids infinite precision. When we try to use both theories to understand what happened in that first moment, we get mathematical nonsense, infinities that can't be resolved, predictions that make no physical sense. This isn't just an abstract theoretical problem. It cuts to the heart of our understanding of reality itself. If our two most successful physical theories contradict each other at the moment of creation, what does that tell us? Perhaps that the Big Bang as we've understood it never happened at all. Perhaps that our concept of beginning is fundamentally flawed. Or perhaps that reality itself is stranger than our theories can currently capture. You might be wondering why this matters. We live in the here and now, after all. The beginning of the universe, whatever it was, happened billions of years ago. But understanding the edge of reality isn't just about satisfying cosmic curiosity. It's about understanding the fundamental nature of existence itself. Consider quantum entanglement, that strange phenomenon where particles become linked in such a way that the state of one instantly influences the state of another, regardless of the distance between them. Einstein called it spooky action at a distance and spent years trying to disprove it. But it's real. We've measured it. We've confirmed it. And we still don't fully understand it. Einstein's objection wasn't just about the strangeness of entanglement. It was about what entanglement implies about the nature of reality. If particles can influence each other instantaneously across vast distances, what does that tell us about space itself? Is space fundamental, or is it emergent, a product of something deeper, something we haven't yet grasped? Recent theoretical work suggests the latter. Space, the arena in which everything happens, the stage on which the cosmic drama unfolds, may itself be a kind of illusion, an emergent property arising from quantum entanglement. Space may not be fundamental at all, but rather a consequence of how quantum information is organized at a deeper level of reality. If that sounds strange, consider this. Time might be an illusion too. In our everyday experience, time seems to flow in one direction, from past to future, never backward. We remember the past, experience the present, and anticipate the future. This apparent flow gives our lives structure, meaning, and coherence. But at the fundamental level of physical law, this distinction largely disappears. Most equations of physics work perfectly well whether time runs forward or backward. The fundamental laws show no preference for one direction of time over another. What we perceive as the flow of time, the distinction between past, present, and future, may be less fundamental than we assume. Some theoretical physicists now argue that time itself is emergent, an approximation that works well at human scales but breaks down as we approach the edge of reality. Imagine a frozen lake in winter. On the surface, it appears solid, stable, unchanging. But if you look closely at the molecular level, you'd see constant motion. Water molecules vibrating, shifting, rearranging. What appears static at one scale is dynamic at another. Similarly, what appears to us as the flow of time may be a surface-level approximation of something far more complex and static at a deeper level of reality. This idea, that time as we experience, it might not be fundamental, isn't just philosophical speculation. It arises naturally from attempts to reconcile quantum mechanics and general relativity. In the quest for a theory of quantum gravity, many approaches suggest that space-time itself, the unified fabric of space and time that Einstein described, emerges from something deeper, something timeless. How can reality be timeless when our experience of time is so powerful, so undeniable? It's like asking a character in a movie to understand that their entire story, past, present, and future, exists simultaneously on the film reel. From within the story, Time flows inexorably from beginning to end. But from outside, the entire story already exists, complete and unchanging. Are we like characters in a cosmic film, experiencing as dynamic and flowing what is actually static and complete? Is the flow of time, that most basic aspect of human experience, actually a kind of necessary illusion, a way for consciousness to make sense of a reality that defies our intuitive understanding? These questions aren't merely philosophical. They have profound implications for our understanding of the Big Bang, of black holes, of reality itself. Because if space and time aren't fundamental, if they emerge from something deeper, then what we call the beginning of the universe may not be a beginning at all. It may be a transition, a change in the way more fundamental entities are organized. This brings us back to the Big Bang, that moment we've long considered the beginning of everything. What if it wasn't a beginning but a phase transition? What if it wasn't the creation of reality, but a reorganization of something that already existed? Several modern cosmological theories suggest exactly this. Loop quantum cosmology, an approach that applies the principles of loop quantum gravity to the entire universe, suggests that the Big Bang was actually a big bounce. In this view, our expanding universe was preceded by a contracting universe that collapsed to an incredibly dense, but not infinitely dense state, before rebounding in what we call the Big Bang. This isn't an isolated speculation. A number of different approaches to quantum gravity, from string theory to causal set theory to asymptotic safety, suggest that the singularity predicted by classical general relativity never actually occurred. Instead, quantum effects become dominant at extreme densities, preventing the formation of a true singularity and potentially allowing for a pre-Big Bang reality. What would such a pre-Big Bang reality look like? We don't know. Our physical theories break down under the extreme conditions near the Big Bang. Our mathematical tools become unreliable. Even our concepts of before and after may lose their meaning when space-time itself is in flux. But here's a thought experiment. Imagine a universe contracting, galaxies rushing toward each other, space itself shrinking. As matter becomes more concentrated, temperatures rise. Atoms break apart into subatomic particles. Those particles break down further into quarks and gluons. Space contracts further. Temperatures soar higher. Eventually, we reach a state where even the concepts of space and time as we understand them cease to be meaningful. And then what? In classical general relativity, we hit a singularity, an ending. But in quantum gravity approaches, something else happens. The contraction stops. The compression reaches a limit. And then expansion begins anew. If this seems hard to visualize, that's because it is. Our minds evolved to understand savanna landscapes and social hierarchies, not quantum geometries and phase transitions in space-time. We're trying to comprehend reality at scales and under conditions that defy our intuitive understanding. But that's precisely what makes these questions so fascinating. We're pushing at the boundaries not just of knowledge, but of comprehension itself. We're reaching for truths that may lie partly beyond what human minds were designed to grasp. And yet, incredibly, we've made progress. Through mathematics, through observation, through theory and experiment, we've pushed our understanding further than our ancestors could have imagined possible. We've detected gravitational waves, ripples in the fabric of space-time itself. We've imaged black holes, objects so dense that light itself cannot escape their gravitational pull. We've measured the cosmic microwave background radiation with extraordinary precision, mapping tiny temperature fluctuations that tell us about the state of the universe when it was just 380,000 years old. But the first fraction of a second after the Big Bang, or before it, or instead of it, remains elusive. It's as if reality has drawn a veil across its deepest mysteries, allowing us to approach but never quite reach the ultimate truth. Or perhaps the truth is approachable, but not in the way we've been trying. Perhaps we've been asking the wrong questions all along. Consider this perspective. What if the Big Bang wasn't the beginning of time, but the beginning of our ability to describe time? What if it wasn't the creation of reality, but the emergence of reality in a form that can be captured by our mathematics, our concepts, our theories? This distinction might seem subtle, but it's profound. It suggests that reality doesn't begin or end. It transforms. It shifts from states we cannot describe to states we can, and perhaps back again. The edge of reality, in this view, isn't a temporal boundary, but a boundary of description, a limit to what our concepts can capture. Does this sound abstract? Consider a simple analogy. Temperature. Temperature measures the average kinetic energy of particles in a system. It's a useful concept that helps us understand and predict how systems behave. But temperature only makes sense when you have enough particles to talk about an average. If you have just one atom, or two, or three, the concept of temperature loses its meaning. It's not that reality breaks down at small scales, it's that our concept of temperature breaks down. Similarly, our concepts of space and time, as useful as they are, may break down as we approach the extreme conditions of the Big Bang. Not because reality ceases to exist, but because our descriptions cease to apply. This perspective shifts the question from what happened at the beginning to how did our familiar reality emerge from conditions so extreme that our current concepts cannot describe them. It's not about finding the first moment of time, but understanding how time itself came to be a useful description of reality. And this, perhaps, is where we should focus our attention. Not on an elusive beginning that may not even be a coherent concept, but on the transition from the inscrutable to the scrutable, from the indescribable to the describable. The most promising approach may lie in understanding quantum gravity, the i.e. elusive theory that would reconcile quantum mechanics and general relativity. Such a theory wouldn't just tell us what happened at the beginning. It would tell us how space and time themselves emerge from something more fundamental. Several candidate theories exist, each with its own mathematical framework, its own strengths, its own challenges. String theory suggests that the fundamental entities aren't particles, but tiny vibrating strings, whose different modes of vibration give rise to different particles. Loop quantum gravity suggests that space itself has a discrete quantum structure, more like a fabric woven from elementary loops than a smooth, continuous medium. These theories, and others, like causal set theory and asymptotic safety, offer different visions of what lies beyond the limits of our current understanding. They suggest different ways in which the familiar concepts of space and time might emerge from something deeper, something stranger. But they all share a common implication.
สบายคือกูได้กายกันนับไปจิตเนี่ยอันนั้นไปให้ฝึกตัวมาวันนั้นอันนั้นคนไทยจะหาว่าอาแบบอินเดียได้กันนั้นเดินกันเดินชนิด
It may be a transition, a phase change, a reorganization of something that always was and always will be. This doesn't mean the Big Bang didn't happen. The evidence for an extremely hot, dense early universe is overwhelming. What it means is that the Big Bang may not have been the absolute beginning of everything, just the beginning of everything we can currently describe and understand. Beyond that lays mystery. Not empty mystery, not a void of knowledge, but a richness too profound for our current concepts to capture. A reality that doesn't begin or end, but transforms. that doesn't pop into existence from nothing, but changes from states beyond our mathematical description to states within it. If this seems to push against the boundaries of comprehension, that's because it does. We're reaching for truths that may lie partly beyond what human minds were designed to grasp. And yet, incredibly, we continue to make progress. Through mathematics, through observation, through theory and experiment, we push our understanding further than our ancestors could have imagined possible. But what if the limitations aren't just in our current theories, but in the very way we construct theories? What if the edge of reality isn't just a boundary of our current understanding, but a boundary of understanding itself? Consider the concept of explanation. When we explain something, we typically reduce it to something more fundamental. We explain chemical reactions in terms of atomic interactions. We explain atomic interactions in terms of quantum mechanics. We explain quantum behaviors in terms of wave functions and probability. Each explanation pushes the fundamental question down a level. But eventually, this chain of explanation must end, or circle back on itself. We must either accept certain things as brute facts, unexplained explainers, or we must accept a circularity in our explanations. Neither option sits well with the human mind. We crave complete explanations that don't rely on unexplained foundations. We want to know why reality is the way it is, not just how it works. We want to know why there is something rather than nothing, why the laws of physics take the form they do, why consciousness exists at all. But what if these questions reach beyond the limits of explanation itself? What if there are truths that cannot be captured in the form of an explanation, a reduction to something more fundamental, because they are themselves the most fundamental things? This isn't to say we should stop asking these questions or seeking these explanations. It's to recognize that the edge of reality may also be the edge of explanation, a place where our quest for deeper understanding transforms into something else, something we can't yet fully articulate. In the face of such profound mystery, it's easy to retreat into comfortable certainties, to cling to stories of cosmic genesis that make intuitive sense, to speak confidently about what happened in the beginning, as if we were there to witness it. But true wisdom lies in embracing the mystery, in acknowledging the limits of our understanding while continuing to push against them, in recognizing that the universe is not just stranger than we imagine, but potentially stranger than we can imagine. This doesn't mean abandoning the quest for knowledge. It means pursuing it with a certain humility, a recognition that our maps of reality, as impressive as they are, remain incomplete, that there are regions marked "Here be dragons," not because we haven't explored them yet, but because they may defy the very concept of mapping. And yet, we continue to explore. We build more powerful telescopes to peer deeper into space and further back in time. We construct more energetic particle accelerators to probe smaller distances and higher energies. We develop more sophisticated mathematical frameworks to describe realms beyond direct observation. Why? Because that's who we are. Because the quest to understand reality, even if it can never be fully completed, is one of the defining features of human consciousness. Because every new discovery, every deeper insight, not only expands our knowledge, but transforms our relationship with the cosmos. We began this exploration with a provocative statement. The Big Bang did not bang. And in a sense, that's true. What we call the Big Bang wasn't an explosion in pre-existing space. It wasn't a moment of creation ex nihilo. It was a transformation from conditions we cannot fully describe to conditions we can. But in another sense, the statement misses the point. Because the Big Bang, whatever it was, wasn't the beginning of reality. It was the beginning of reality as we can comprehend it, as we can model it with our mathematics, as we can speak about with our concepts. Beyond that lies mystery. Not empty mystery, not a void of knowledge, but a richness too profound for our current frameworks to capture. A reality that may not begin or end but transforms, that may not be created or destroyed but changes from states beyond our current comprehension to states within it. As we continue our journey tonight, keep this in mind. We're not just exploring the outer reaches of the cosmos or the earliest moments of cosmic history. We're exploring the boundaries of comprehension itself, the edge where reality meets understanding. And what we find there may transform not just our view of the universe, but our understanding of what it means to understand at all. The edge of reality isn't just a place, it's a relationship between mind and cosmos, between the finite and the infinite, between the known and the unknowable. And as we approach that edge, we may find that the greatest mystery isn't what lies beyond, but how we came to exist in a universe we can comprehend at all. Because that, perhaps, is the greatest mystery of all. Not that the universe exists, but that it exists in a form that can give rise to minds that seek to understand it. That the same processes that forged stars and galaxies also forged consciousness, awareness that can turn back and contemplate its own origins. In the words of physicist Eugene Wigner, this is the unreasonable effectiveness of mathematics in the natural sciences. The astonishing fact that the human mind, through abstract reasoning, can uncover the deep structure of physical reality, as if the universe were not just comprehensible, but comprehensible to us. Is this a profound truth about reality, that it has an inherent mathematical structure waiting to be discovered? Or is it a profound truth about consciousness, that we can only perceive and conceptualize reality in ways that our minds can structure and organize? Perhaps both. Perhaps neither. Perhaps the distinction itself becomes meaningless at the edge of reality, where observer and observed, mind and matter, knowledge and being all intersect. What we can say with certainty is this: we exist in a universe of astonishing complexity and beauty, one that somehow gave rise to minds that can contemplate that complexity and appreciate that beauty, and the journey to understand it, however incomplete it may remain, is one of the most profound adventures consciousness can undertake. So let us continue that journey, past the surface of last scattering, through the plasma-filled early universe, to the very edge of what we can know and perhaps beyond, not with the expectation of finding a neat, complete answer, but with an openness to mystery, to transformation, to the possibility that reality itself may be forever beyond the reach of final explanation. Not because it is empty or meaningless, but because it is too rich, too fundamental, too all-encompassing to be reduced to anything else. And perhaps in that humility, in that openness to mystery, we find not the answer to reality, but a deeper relationship with it. Not an explanation of existence, but a more profound way of existing. Not a resolution of cosmic paradox, but a way of living within it. Because in the end, we are not separate from the reality we seek to understand. We are expressions of it, manifestations of the same cosmic process that forged stars and galaxies. The edge of reality isn't just out there in the distant cosmos or the earliest moments of time. It's here, now, in the awareness that reads these words, that contemplates these mysteries, that reaches for understanding, even as it acknowledges the limits of what can be understood. And perhaps that's the greatest revelation of all, that in seeking the edge of reality, we discover not just the boundaries of the cosmos, but the boundaries and the boundlessness of consciousness itself. For centuries, we've gazed at the night sky, believing it told a simple story. The universe began, expanded, and will one day end. A linear narrative with a clear beginning, middle, and eventual conclusion. But what if that narrative, that comforting bedtime story we tell ourselves about cosmic origins, is merely our mind's attempt to impose order on something fundamentally beyond our comprehension? Let's start with what we think we know. The observable universe spans approximately 93 billion light-years in diameter. Not 13.8 billion, as you might expect from its age, but 93 billion, because space itself has been stretching, carrying galaxies away from each other faster than their light can travel between them. Already, we confront our first paradox. The universe is younger than it is wide. Picture yourself standing on the shore of a vast cosmic ocean. The water before you stretches to a horizon, the edge of what you can see. But that horizon isn't the edge of the ocean. It's merely the limit of your vision. Similarly, the edge of our observable universe isn't the edge of the universe itself. It's merely the boundary of what light has had time to reach us since the Big Bang. Beyond that boundary, space almost certainly continues, perhaps infinitely. But infinity presents its own paradoxes. If the universe extends forever in all directions, then it must contain infinite matter, infinite stars, infinite possibilities. In an infinite universe, everything that can happen does happen. Not just once, but an infinite number of times. Somewhere, impossibly far away, another you is reading these exact words, and another you decided to watch something else entirely, and another you never existed at all. Can infinity be real? Or is it merely a mathematical convenience, a concept we use when our equations break down? The ancient Greeks were so disturbed by the concept of infinity that they banned it from their mathematics. Perhaps they understood something we've forgotten, that infinity isn't just large, it's qualitatively different, a concept that breaks the very rules of arithmetic and logic. Yet modern cosmology suggests the universe might indeed be infinite. The curvature of space, as best we can measure it, appears to be flat, which implies an infinite extent. But here's where things get truly strange. Even if the universe is finite, it may have no edge. Imagine an ant walking on the surface of a sphere. The ant can travel in any direction without ever reaching an edge, yet the surface it walks on is finite. Similarly, our three-dimensional space could curve through a fourth spatial dimension, closing in on itself without ever presenting a boundary. We would never find the edge of the universe for the same reason the ant never finds the edge of the sphere. Not because it's infinitely large, but because it's geometrically complete. This raises a profound question. If the universe has no edge, then where does it begin? How can something have a beginning in time but no boundary in space? The conventional answer involves separating space from time. The universe began as a singularity that expanded in three spatial dimensions, while time ticked forward as a separate dimension. But this neat separation breaks down under the weight of Einstein's relativity, which tells us that space and time are aspects of a single entity: space-time. The early universe wasn't just hot. It was a furnace where time itself was still learning to move. Near the Big Bang, the distinction between space and time blurs. The beginning wasn't a moment in time as we understand it, but a boundary condition of space-time itself. Perhaps asking what came before the Big Bang is like asking what's north of the North Pole. It's a question that assumes a dimension of movement that doesn't exist at that boundary. But this conventional picture, elegant as it seems, hides deeper mysteries. One of these is the horizon problem, the unexplained uniformity of the cosmic microwave background radiation. When we look at the afterglow of the Big Bang, that ancient light that bathes us from all directions, we find it's remarkably consistent in temperature. varying by only about 1 part in 100,000 across the entire sky. This uniformity is puzzling because regions on opposite sides of our sky were causally disconnected in the early universe. Light, and therefore information, didn't have time to travel between them. It's as if two people who never communicated somehow showed up to a party wearing identical outfits down to the smallest detail. The standard explanation is cosmic inflation, a hypothesized period of exponential expansion in the first fraction of a second after the Big Bang. During inflation, a tiny, causally connected region of space expanded so rapidly that it became our entire observable universe. This explains the uniformity. The whole sky was once small enough for every part to be in thermal contact. Inflation is an elegant solution that resolves several cosmological puzzles simultaneously. It explains why space appears flat. It explains why we don't see magnetic monopoles. It explains why the universe's large-scale structure resembles quantum fluctuations blown up to cosmic proportions. But inflation comes with its own disturbing implications. The mathematics that gives us inflation doesn't just predict our universe. It predicts a potentially infinite number of universes, constantly bubbling into existence, each with its own laws of physics, its own constants, its own possibilities. Our universe, in this picture, is just one bubble in an endless, frothing sea of cosmic creation. Not the universe, but a universe, one island of order in an archipelago that stretches beyond comprehension. This multiverse concept isn't just speculation. It emerges naturally from the mathematics of inflation, from string theory, from quantum mechanics interpreted literally. It's what our best theories predict when pushed to their logical conclusions. And it utterly transforms our cosmic narrative from a story about one universe with one beginning to a story about an endless proliferation of realities, each with its own cosmic history. If the multiverse is real, then the Big Bang that created our observable universe wasn't the beginning of everything, just the beginning of our local bubble of reality. And the true cosmic story becomes vaster, stranger, and more vertigo-inducing than we ever imagined. But let's pull back from these speculative frontiers and return to more solid ground, the observable universe and its history as revealed by light. When we look at distant galaxies, we see them as they were in the past, not as they are now. Light from the Andromeda galaxy takes 2.5 million years to reach us, so we see it as it was when early humans were first using stone tools. Light from distant quasars shows us the universe as it was billions of years ago, when the first galaxies were still forming. This cosmic look-back time gives us a direct view of the universe's history. By observing objects at different distances, we've pieced together a remarkably detailed timeline of cosmic evolution, from the first stars igniting in the cosmic dark ages to the formation of galactic structures to the acceleration of cosmic expansion we observe today. This timeline tells a story of transformation, from the hot, dense, simple early universe to the cool, diffuse, complex one we inhabit. It's a story of increasing complexity, of matter organizing itself into ever more intricate structures, from formless plasma to atoms, from atoms to molecules, from molecules to stars and planets, from planets to the intricate chemical systems we call life. But this story of increasing complexity confronts a profound physical paradox, the second law of thermodynamics, which tells us that the universe as a whole should be moving toward greater disorder, not greater order. How can a universe governed by entropy, by the inevitable slide toward disorder, give rise to the astonishing complexity we see around us? How can a process that should disorganize create galaxies, planets, ecosystems, brains? The resolution of this paradox lies in understanding that order can emerge locally, even as disorder increases globally. The formation of a star, for instance, creates an organized system, but it does so by radiating enormous amounts of heat into space, increasing the total entropy of the universe. Life on Earth creates astonishingly complex systems, but it does so by consuming energy from the sun and releasing heat, again increasing total entropy. Complexity, in this view, isn't a violation of the second law. It's a consequence of how energy flows through open systems. The universe as a whole may be winding down, but within it, pockets of remarkable organization can emerge, persist, and evolve. This understanding transforms our cosmic narrative yet again. The universe isn't simply expanding and cooling, it's creating the conditions for complexity to emerge, for matter to organize itself into systems of increasing intricacy and capability. From this perspective, conscious observers like ourselves aren't accidents or anomalies. We're expressions of the universe's fundamental tendency to explore states of higher complexity as it seeks pathways to dissipate energy. But this brings us to another paradox: the fine-tuning problem. The physical constants that govern our universe, the strength of gravity, the mass of the electron, the strength of the nuclear forces, appear to be exquisitely calibrated to allow for complexity. Change any of these values by even a small amount, and stars couldn't form, or chemistry couldn't function, or complex structures would be impossible. The gravitational constant, for instance, determines how strongly matter attracts other matter. If it were slightly stronger, stars would burn too hot and too briefly for life to evolve. If it were slightly weaker, stars couldn't form at all. Similarly, precise calibrations apply to dozens of other physical constants. Why should the fundamental parameters of physics happen to fall in the narrow ranges that permit complexity? Is the universe designed for life and consciousness? Or is there some deeper principle at work that we haven't yet grasped? The multiverse offers one potential explanation. If there are countless universes with different physical laws, we naturally find ourselves in one of the few that permits our existence. Just as fish don't marvel at how perfectly water suits their gills, they simply couldn't exist in environments without water. Perhaps we shouldn't marvel at how perfectly our universe suits consciousness. In a vast enough multiverse, consciousness would naturally arise in those rare bubbles where it's physically possible. But this anthropic reasoning doesn't tell us why a multiverse should exist in the first place, or why it should generate universes with varying physical laws. It pushes the question back a level. Instead of asking why our universe is fine-tuned for complexity, we ask why reality generates a multiverse that includes universes like ours. Perhaps we're approaching these questions from the wrong direction. Perhaps, as the physicist John Wheeler suggested, the relationship between consciousness and physical reality is more intimate and circular than we've assumed. Wheeler proposed what he called the participatory anthropic principle, the idea that the universe requires observers to bring it into existence, not just philosophically, but physically. In the words of his famous dictum, "No phenomenon is a physical phenomenon until it is an observed phenomenon." This isn't mere philosophical speculation. It emerges from the quantum measurement problem, the mysterious relationship between observation and physical reality at the quantum level. When unobserved, quantum systems exist in superpositions of multiple states simultaneously. Only when measured do they collapse into definite states. Taken to its logical conclusion, this suggests that reality as we know it, with definite positions, definite histories, definite structures, may emerge from the interaction between consciousness and something more fundamental, more fluid, more indeterminate. Wheeler illustrated this with his delayed choice experiments, which suggest that observations made in the present can retroactively determine the path a particle took in the past. If true, This means causality itself, our most basic assumption about how reality works, may be more subtle and circular than our linear thinking suggests. The implications are dizzying. If observation plays a role in determining reality, and if observers only emerge in universes capable of supporting them, then the fine-tuning problem takes on a different character. Perhaps universes and observers co-create each other in a loop of causality that transcends linear time. But let's pull back once again from these speculative frontiers and return to more concrete mysteries, the dark components of our universe. 2. Astronomers measure the rotation of galaxies. They find the outer regions spin too fast for the visible matter to hold them together gravitationally. Galaxies should be tearing themselves apart, unless they contain far more mass than we can hold as such. See, this missing mass, which doesn't emit or absorb light but makes its presence known through gravitational effects, is what we call dark matter. Dark matter isn't just a minor correction to our cosmic model. It appears to make up about 85% of all matter in the universe. The stars, planets, gas clouds, black holes, everything we can see directly or indirectly through electromagnetic radiation constitute a mere 15% of the universe's matter. Think about that for a moment. After centuries of astronomical observation, after building telescopes that can see in every wavelength from radio to gamma rays, after mapping the sky with unprecedented precision, we've been studying only a small fraction of what's actually out there. It's as if we've been reading a book with most of the pages missing, trying to piece together the plot from the few pages we can see. What is this invisible substance that outweighs all visible matter more than 5-to-1? We don't know. It could be comprised of weakly interacting massive particles, theoretical entities that rarely interact with ordinary matter. It could be axions, hypothetical particles proposed to solve problems in quantum chromodynamics. It could be primordial black holes formed in the early universe. It could be something we haven't even conceived of yet. What we do know is that dark matter doesn't seem to interact with ordinary matter or light except through gravity. It doesn't clump into stars or planets. It doesn't form atoms or molecules. It passes through ordinary matter like a ghost through a wall. Yet its gravitational influence shapes the entire visible universe, providing the scaffolding around which galaxies and galaxy clusters form. But dark matter is only the beginning of the mystery. When astronomers measure the expansion of the universe, they find it's not slowing down as expected, but accelerating. Something is pushing space itself apart, overcoming the gravitational attraction of all matter, both dark and visible. We call this mysterious repulsive force dark energy, and it constitutes about 68% of the total energy content of the universe. Dark matter makes up about 27%. All the visible matter, all the stars, planets, nebulae, galaxies that we can see, account for less than 5%. Let that sink in. The universe as we know it, the stars overhead, the ground beneath your feet, your own body, represents less than 5% of what exists. We are, in a very real sense, the exception rather than the rule. The universe is primarily composed of things we cannot see, cannot touch, and do not understand. Dark energy isn't just mysterious, it's profoundly counterintuitive. Everything we observe directly, from thrown balls to orbiting planets, eventually slows down due to various forms of resistance. But the universe's expansion is speeding up, as if the cosmic race is being run downhill, with gravity somehow acting in reverse on the largest scales. What could dark energy be? One possibility is that it's a property of empty space itself, a cosmic constant embedded in the fabric of spacetime. Einstein originally introduced such a constant into his equations to create a static universe, then abandoned it when observations revealed the universe was expanding. Now it's back, but with the opposite sign, pushing space apart rather than holding it together. But a cosmic constant raises its own profound questions. If dark energy is a property of empty space, why does it have the value it does? Quantum field theory attempts to calculate the energy of the vacuum from first principles and gets an answer that's off by 120 orders of magnitude. This has been called the worst theoretical prediction in the history of physics. Perhaps dark energy isn't constant, but dynamic, a field that changes over time, perhaps oscillating between attractive and repulsive phases. Perhaps it's a sign that Einstein's theory of gravity, for all its confirmed predictions, is incomplete on the largest scales. Perhaps it's something stranger still, a hint that reality at its largest scales operates according to principles we haven't yet grasped. What's certain is that dark energy will determine the ultimate fate of our universe. If it remains constant, the universe will continue to expand at an accelerating rate. Galaxies beyond our local group will recede beyond our cosmic horizon, their light stretched to invisibility by the expanding space between us. Eventually, even neighboring galaxies will vanish from view. In the far future, observers would see only their own galaxy in an otherwise empty universe, all evidence of the broader cosmos having disappeared beyond a darkened horizon. It's a chilling thought, a universe that gradually erases its own history, that removes from view the very evidence that once revealed its nature to beings like us. Future cosmologists, should they exist, would have no way to discover dark energy, no way to measure the universe's acceleration, no way to reconstruct its history. The evidence would have disappeared beyond their cosmic horizon. Unless, of course, something fundamental changes in our understanding. Unless dark energy reveals itself to be more complex than a simple constant. Unless the universe has more surprises in store. And this brings us to perhaps the most profound mystery of all: the nature of space and time themselves. We tend to think of space as an empty stage, a passive backdrop against which the cosmic drama unfolds. But Einstein showed us that space is dynamic, that it bends in the presence of mass and energy, that what we experience as gravity is actually the curvature of space-time. This understanding transformed the way we think about the cosmos. Black holes aren't objects in space. They're regions where space itself has collapsed under its own gravitational pull. The Big Bang wasn't an explosion in pre-existing space. It was the birth of space itself. The expansion of the universe isn't matter, moving through space. It's space itself stretching, carrying matter along with it. But quantum mechanics suggests that space may be even stranger than Einstein imagined. At the smallest scales, the Planck length, about 10 to around 35 meters, space may not be continuous at all. It may have a granular structure, a fundamental graininess that defines the smallest possible distance, just as matter, once thought to be continuous, reveals itself to be composed of atoms. Space itself may be composed of discrete units, atoms of distance, and time may be quantized as well, divided into indivisible moments, the smallest ticks on the cosmic clock. The smooth flow of time that we experience may be an approximation, a blur that emerges when we're unable to resolve reality's underlying digital nature. This quantization of space-time isn't just a theoretical curiosity. It emerges naturally from attempts to reconcile quantum mechanics with general relativity, our two most successful physical theories, both exhaustively tested, yet fundamentally incompatible with each other. General relativity describes a smooth, continuous, deterministic space-time warped by matter and energy. Quantum mechanics describes a lumpy, probabilistic, indeterministic reality, where particles aren't particles and waves aren't waves. Both theories work brilliantly in their domains: general relativity for the very large, quantum mechanics for the very small. But when we try to use them together, as we must when describing black holes, the early universe, or the nature of space-time itself, they produce nonsensical infinities and logical contradictions. Something has to give. Either general relativity is incomplete, or quantum mechanics is incomplete, or both are approximations of a deeper theory we haven't yet discovered. Enter quantum gravity, the holy grail of theoretical physics, the theory that would unify our understanding of reality at all scales. We don't yet have a complete, tested theory of quantum gravity, but several approaches show promise: string theory, loop quantum gravity, causal set theory, asymptotic safety, and others. These approaches differ in their details, but they share a common implication. Space-time, as we understand it, is not fundamental. It emerges from something deeper, something more primary, something that isn't space and isn't time, but gives rise to both when viewed at the right scale. In string theory, for instance, the fundamental entities aren't particles located at points in space, but tiny vibrating strings that create the illusion of particles and the illusion of space itself through their interactions. The mathematics suggests that these strings vibrate in 10 or 11 dimensions, most of which are compactified, curled up too small to detect, leaving the 3 extended spatial dimensions we experience. In loop quantum gravity, space itself has a discrete quantum structure, more like a network of interconnected loops than a smooth, continuous medium. What we experience as space emerges from the relationships between these loops, just as the smooth surface of water emerges from the collective behavior of countless H2O molecules. In causal set theory, space-time is fundamentally discrete, composed of elementary events connected by causal relationships. The smooth space-time of general relativity emerges as an approximation when we view these causal sets at large scales, much as a digital photograph appears continuous when viewed from a distance despite being composed of discrete pixels. These approaches raise a profound possibility. Space and time as we experience them may not be the fundamental context of reality, but emergent properties arising from deeper, more primary structures. The stage upon which the cosmic drama unfolds may itself be part of the drama. Not the setting, but an actor. This brings us full circle to the mystery of the Big Bang. If space and time themselves are emergent rather than fundamental, then asking what came before the Big Bang becomes not just conceptually difficult, but potentially meaningless. It's like asking what's south of the South Pole, a question based on a directional concept that breaks down at that point. The Big Bang may not have been the beginning of everything, but the beginning of space-time as we understand it. A phase, transition in something more fundamental, a reorganization of reality's basic structure. What we call the beginning may be merely the limit of our current descriptive framework, the point where our concepts of before and after, here and there cease to apply. If this seems abstract, consider a simple analogy. Temperature. Temperature measures the average kinetic energy of particles in a system. It's a useful concept that helps us understand and predict how materials behave. But temperature only makes sense when you have enough particles to talk about an average. If you have just one atom, or 2, or 3, the concept of temperature loses its meaning. It's not that reality breaks down at small scales. It's that our concept of temperature breaks down. Similarly, our concepts of space and time, as useful as they are, may break down as we approach the extreme conditions of the Big Bang. Not because reality ceases to exist, but because our descriptions cease to apply. This perspective shifts the question from what happened at the beginning to how did our familiar space-time emerge from conditions so extreme that our current concepts cannot describe them? It's not about finding the first moment of time, but understanding how time itself came to be a useful description of reality. And perhaps this is what we should expect. After all, human concepts evolved to help our ancestors navigate the African savanna, to track prey, avoid predators, interpret social hierarchies, find mates. That these same conceptual tools should apply seamlessly to the nature of reality at its most fundamental level would be surprising indeed. What we call time may be a cognitive map created by evolving brains to track sequences of events. What we call space may be our perceptual system's way of organizing sensory data. These maps work remarkably well for many purposes. They've kept our species alive and led to astonishing technological achievements. But, like all maps, they simplify, they approximate, they leave things out. And when we push them to their limits, to the very large, the very small, the very hot, the very dense, they begin to show their limitations. This doesn't mean our maps are wrong, just incomplete. Newton's laws of motion weren't invalidated. By Einstein's relativity, they were revealed to be approximations that work extremely well within certain limits. Similarly, our intuitive concepts of space and time aren't wrong. They're approximations that work extremely well at human scales, but break down as we approach the fundamental limits of reality. If space and time are emergent rather than fundamental, what gives rise to them? What is the deeper substrate from which our familiar reality emerges? Various theories offer different answers. Quantum fields, strings, loops, causal sets, information, computation. But they all suggest a reality more abstract, more mathematical, more alien to our intuition than the space-time we experience. Perhaps the fundamental nature of reality isn't physical in any sense we currently understand. Perhaps it's mathematical, not just described by mathematics, but constituted by it. Perhaps it's informational, a vast process of computation, with our physical universe as one possible output. Perhaps it's something we cannot currently conceptualize, something beyond our cognitive reach, something for which we have not yet evolved the necessary mental tools. This may sound like speculation, but it's speculation driven by our best physical theories and our most precise observations. It's where the evidence points when we follow it to its logical conclusions. And it's humbling in its implications, suggesting that reality itself may be stranger, more fundamental, and more profound than our minds were designed to grasp. Yet we continue to make progress through mathematics, through observation, through theory and experiment. We push our understanding further than our ancestors could have imagined possible. We detect gravitational waves, ripples in the fabric of space-time itself. We image black holes, objects so dense that they warp space and time beyond recognition. We measure the cosmic microwave background radiation with extraordinary precision, mapping tiny temperature fluctuations that tell us about the state of the universe when it was just 380,000 years old. Each new discovery brings us closer to the edge of reality, the boundary where our current understanding breaks down and something new begins. And each new theory suggests that this edge isn't just a limit of our current knowledge, but a fundamental transition in the nature of reality itself. The universe we observe, with its galaxies and stars, its planets and moons, its living systems, and conscious observers, may be just the visible surface of something far deeper, far stranger, far more fundamental, a surface that ripples and shifts as processes beyond our comprehension unfold in depths we can barely imagine. If the universe has no edge, then where does it begin? Perhaps nowhere, perhaps everywhere. Perhaps the question itself assumes a linear narrative that reality does not follow. Perhaps the universe doesn't begin at all, but emerges, continuously, eternally, in an endless process of creation that has no first moment, no initial condition, no ultimate origin. And if that's true, then our search for the beginning isn't a journey to the edge of time, but a descent into the depths of reality. A movement not backward but inward, toward the fundamental nature of existence itself. This perspective transforms the way we think about the cosmos and our place within it. We're not just observers of a universe that began long ago and will end in the distant future. We're expressions of a cosmos that creates itself continuously, that has no absolute beginning or end, that exists in a perpetual state of emergence. And our consciousness, our ability to perceive, to think, to wonder about these mysteries, isn't separate from this process of cosmic emergence. It's an aspect of it, a way that the universe has evolved to explore its own nature, to map its own contours, to contemplate its own existence. In a very real sense, our search for the edge of reality, for the beginning of time, for the nature of space, for the fundamental structure of existence, is the universe searching for itself through us. Our questions are its questions. Our wonder is its wonder. Our theories are its theories. And perhaps that's the most profound mystery of all. Not that the universe exists, but that it exists in a form that can give rise to minds that seek to understand it. That the same processes that forged stars and galaxies also forged consciousness, awareness that can turn back and contemplate its own origins. As we continue our journey tonight, keep this in mind. We're not just exploring the outer reaches of the cosmos or the earliest moments of cosmic history. We're exploring the boundaries of comprehension itself, the edge where reality meets understanding. And what we find there may transform not just our view of the universe, but our understanding of what it means to understand at all. Because in the end, the edge of reality isn't just out there in the distant cosmos or the earliest moments of time. It's here, now, in the awareness that reads these words, that contemplates these mysteries, that reaches for understanding even as it acknowledges the limits of what can be understood. And perhaps that's where our true journey begins. Now we venture into deeper waters, where the familiar shores of established science recede from view, and the vast, uncharted ocean of cosmic mystery stretches before us. We've established the stage, a universe of unfathomable scale, composed primarily of substances we cannot directly observe, expanding at an accelerating rate for reasons we don't fully understand. But this is merely the prologue to our true journey. Let us begin with singularities, those points where our mathematics breaks down, where physical quantities become infinite, where reality itself seems to tear at the seams. Black holes harbor such singularities at their cores. The Big Bang appears to have emerged from such a singularity. These aren't merely regions of extreme density or temperature. They represent the boundaries of our physical theories, the edge cases where our most successful models of reality fail catastrophically. Imagine standing at the event horizon of a supermassive black hole. Before you lies a darkness more profound than the absence of light, the absence of space itself. Cross that boundary, and you enter a region where space and time exchange roles. Just as you cannot help but move forward in time in the normal universe, inside the event horizon, you cannot help but move toward the singularity at the center. The direction that was once toward the black hole becomes toward the future. Your fate is sealed not by forces you could theoretically resist, but by the very geometry of space-time itself. At the center awaits the singularity, a point of infinite density and zero volume, where space-time curvature becomes infinite. At least, that's what general relativity predicts. But we know general relativity must break down under these conditions. No physical theory can accommodate true infinities. Something else must happen. Something our current mathematics cannot describe. Here is where quantum gravity enters our story. Not as a fully formed theory, but as a quest, perhaps the ultimate quest in theoretical physics. What happens when quantum effects become significant in regions of extreme space-time curvature? How does quantum mechanics, our theory of the very small, reconcile with general relativity, our theory of the very large, under these extreme conditions? We don't yet have a complete answer, but various approaches to quantum gravity suggest that singularities aren't truly singular. They're not infinitely dense points, but structures with finite, though extreme, properties. String theory suggests that the fundamental entities aren't point particles, but tiny vibrating strings. These strings have a finite size. The Planck length, about 10 feet 35 meters. This finite size provides a natural cutoff that prevents true infinities from arising. In string theory, what appears as a singularity from far away resolves into a complex tangle of strings when viewed at the Planck. Scale-loop quantum gravity provides a different perspective. It suggests that space itself has a discrete quantum structure, like a fabric woven from elementary loops. These loops have a minimum size, again preventing the formation of true singularities. In this view, a black hole singularity isn't a point of infinite density, but a region where space-time reaches its maximum possible density, still extreme, but finite. Both approaches suggest that reality has a minimum scale, a fundamental graininess below which concepts like smaller cease to have meaning. Just as you cannot have a fraction of an atom or a portion of a quantum, you cannot have a distance smaller than the Planck length or a duration shorter than the Planck time. This quantization of space-time isn't just a theoretical curiosity. It has profound implications for our understanding of the Big Bang, black holes, and the nature of reality itself. Consider the Big Bang. In the classical picture, rewinding the cosmic film leads to a singularity, a point of infinite density and temperature, where space and time themselves begin. But quantum gravity suggests something else, a big bounce rather than a big bang. In loop quantum cosmology, an application of loop quantum gravity to the entire universe, the early universe reached a state of maximum density before rebounding. The Big Bang, in this picture, wasn't the beginning of everything but a phase transition, a moment when a contracting universe reversed course and began to expand. This raises a tantalizing possibility. Our universe may have existed before the Big Bang, in a state very different from what we observe today. The Big Bang wasn't creation ex nihilo, something from nothing, but transformation, the metamorphosis of a pre-existing reality into the form we now observe. Imagine reality as a film reel, where time is not flowing, but every moment already exists. Now imagine that film isn't a linear strip, but a loop, or perhaps a Mobius strip with a twist. There's no true beginning or end, just a continuous sequence that cycles back on itself, perhaps with transformations along the way. But this analogy, like all analogies, has limits. It suggests a deterministic universe, where everything is fixed, where free will is an illusion, where the future is as immutable as the past. Quantum mechanics tells a different story. Quantum level, reality is fundamentally probabilistic. Particles don't have definite positions until observed. Events don't have definite outcomes until they occur. The future isn't written. It's a cloud of possibilities that collapses into a single reality only as that future becomes the present. This inherent indeterminism isn't a limitation of our knowledge or our measurement techniques. It appears to be a fundamental feature of reality itself. The universe doesn't just appear random. At its smallest scales, it is random, or at least probabilistic, in a way that defies classical causality. How can we reconcile this quantum indeterminism with the apparent determinism of the cosmic film reel? How can the future be both unwritten at the quantum level and yet part of a timelessly existing whole? This paradox lies at the heart of our quest to understand reality at its most fundamental level. Perhaps the resolution lies in the many worlds interpretation of quantum mechanics, the idea that every possible outcome of every quantum event actually occurs, each in a separate branch of reality. In this view, the cosmic film reel isn't a single strip, but an infinitely branching tree, with new realities constantly sprouting from each quantum choice point. Imagine that every decision you've ever made and every decision you didn't make spawned a new universe. In one, you turned left. In another, you turned right. In one, you pursued music. In another, mathematics. In one, you spoke. In another, you remained silent. Every possibility realized, every path taken, not by different versions of you, but by you in different versions of reality. If true, this means that parallel versions of you exist, countless versions living out every possible variation of your life. Some nearly identical to your current experience, differing perhaps only in the position of a single subatomic particle. Others radically different, where key life decisions led to entirely different outcomes. This isn't science fiction, it's a serious interpretation of quantum mechanics, endorsed by many respected physicists. It emerges naturally from taking the mathematics of quantum theory literally, without adding the extra postulate of wave function collapse. And yet, it stretches credulity. The notion that reality splits into multiple branches with each quantum event implies an unimaginably vast, perhaps infinite number of parallel worlds, all as real as our own. It's mathematically elegant, but ontologically extravagant, multiplying entities far beyond what Occam's razor would seem to allow. But perhaps Occam's razor needs resharpening when we approach the edge of reality. Perhaps simplicity of mathematics should take precedence over simplicity of ontology. Perhaps reality is under no obligation to conform to our intuitive sense of what's reasonable or economical. The many worlds interpretation isn't the only attempt to make sense of quantum weirdness. The Copenhagen interpretation, historically the most widely accepted, suggests that quantum systems exist in superpositions of multiple states until observed, at which point they collapse into a single definite state. But this raises profound questions about the role of observation and consciousness in the physical world. What constitutes an observation? Must it involve consciousness? Or can any physical interaction serve as an observation that collapses? The wave function. If the latter, what counts as a sufficient interaction? If the former, how can consciousness, seemingly an emergent property of complex physical systems, have such a fundamental effect on physical reality? The physicist Eugene Wigner proposed a thought experiment that pushes this paradox to its limit. Imagine a friend inside a sealed laboratory performing a quantum measurement. Until you open the door and ask about the result, is your friend in a superposition of having observed different outcomes? Or does their consciousness collapse the wave function before you enter? And what about your consciousness? Is it somehow privileged over theirs? These questions aren't merely philosophical. They strike at the heart of our understanding of reality, consciousness, and the relationship between the two. They suggest that the division between observer and observed, between subject and object, may not be as fundamental as we've assumed. This leads us to another interpretation, quantum information theory, which suggests that information, not matter, or energy, is the fundamental currency of reality. In this view, What exists are not particles or waves, but relationships, patterns of correlation between events. Reality emerges from the way these correlations are structured, not from the physical substrate that embodies them. Imagine reality not as a collection of objects moving through space, but as a vast network of information, a cosmic computation unfolding according to algorithmic rules. Physical objects, in this view, are stable patterns in the flow of information, like whirlpools in a river. They have persistence and causal power, but they aren't fundamental. They're emergent structures in a deeper informational reality. This perspective aligns with recent developments in theoretical physics, particularly the holographic principle, the idea that the information contained in a region of space can be represented by information on the boundary of that region. First proposed in the context of black hole thermodynamics, this principle suggests that our three-dimensional reality may be mathematically equivalent to a two-dimensional information structure, like a hologram encoding three-dimensional information on a flat surface. If true, this means space itself, the arena in which everything seems to happen, may be a kind of illusion, a way of organizing information that exists in a more fundamental, non-spatial form. The three dimensions we experience may be a useful approximation, a way for our minds to organize and understand patterns that exist in a deeper reality with different fundamental properties. This isn't to say that space isn't real. It's real. In the same way that temperature is real, it's a property that emerges at certain scales and under certain conditions, a useful way of describing collective behavior that doesn't apply at more fundamental levels. At the quantum scale, space appears to become lumpy, uncertain, non-local. Distant particles can be entangled, influencing each other instantly regardless of the space between them, not because they're exchanging signals faster than light, but because their separation in space is in some sense less fundamental than their entanglement in the underlying informational structure. What we call locality in physics, the principle that objects can only be directly influenced by their immediate surroundings, may be an emergent property rather than a fundamental law. Just as classical physics emerges from quantum physics under certain conditions, locality may emerge from a deeper non-local reality when viewed at the right scale. This brings us to another radical idea: time as an emergent property. We experience time as a flow, as a sequence of moments, as an irreversible progression from past to future. But at the fundamental level of physical law, this distinction largely disappears. Most equations of physics work perfectly well, whether time runs forward or backward. They show no preference for one direction of time over another. The apparent flow of time, what physicists call the arrow of time, seems to be connected to entropy, to the tendency of isolated systems to evolve from order to disorder. We remember the past, but not the future, because the past had lower entropy than the present. We age in one direction because that's the direction of increasing entropy. We can scramble an egg, but not unscramble it, because unscrambling would require a decrease in entropy. This thermodynamic arrow of time gives us the sense that time flows in one direction. But some physicists suggest that this flow may not be fundamental, that time itself may be emergent, a way of organizing events that has no counterpart in the deeper reality. Imagine a frozen lake in winter. On the surface, it appears solid, stable, unchanging. But if you look closely at the molecular level, you'd see constant motion. Water molecules vibrating, shifting, rearranging. What appears static at one scale is dynamic at another. Similarly, what appears to us as the flow of time may be a surface-level approximation of something far more complex and static at a deeper level of reality. This idea, that time as we experience, it might not be fundamental, isn't mere philosophical speculation. It emerges naturally from attempts to reconcile quantum mechanics and general relativity. In the quest for a theory of quantum gravity, many approaches suggest that space-time itself, the unified fabric of space and time that Einstein described, emerges from something deeper, something timeless. The physicist Julian Barbour has developed a theory called timeless physics, or shape dynamics, in which time isn't a fundamental dimension, but a way of comparing different configurations of the universe. In this view, what exists isn't a universe evolving through time, but a vast collection of possible configurations, a landscape of nows, with no inherent temporal ordering. The sense of time passing, in this view, comes from the way our consciousness navigates through this landscape, from the way our memories work, from the way entropy manifests in the configurations we experience. Time isn't flowing. We are. Or rather, what we call we is a series of related configurations in this timeless landscape linked by similarity, causality, and memory. If this seems hard to visualize, that's because it is. Our minds evolved to understand time as a flow, to navigate a world where cause precedes effect, where actions have future consequences, where planning requires anticipating what comes next. A timeless reality defies these intuitions. It requires us to think in ways our brains weren't designed for. But mathematics allows us to explore concepts our intuition struggles with. And the mathematics of quantum gravity increasingly points toward timelessness as a fundamental feature of reality, with time emerging only at larger scales, under certain conditions, as an approximation that works well for creatures like us, but breaks down as we approach the edge of reality. This brings us back to our original mystery, the nature of the Big Bang. If time itself is emergent rather than fundamental, then asking what came before the Big Bang becomes not just conceptually difficult, but potentially meaningless. It's like asking what's north of the North Pole, a question based on a directional concept that breaks down at that point. The Big Bang may not have been the beginning of everything, but the beginning of time as we understand it, a phase transition in a deeper, timeless reality, a reorganization of fundamental structures that gave rise to the flowing time we experience. This doesn't mean the quest to understand the Big Bang is futile. On the contrary, it means we need to approach it with more subtle, more sophisticated concepts, acknowledging that our everyday notions of before and after, creation and destruction, beginning and end may not apply at the most fundamental levels of reality. Let's shift our perspective and explore another radical theory, the multiverse. Not just the many worlds interpretation of quantum mechanics, which posits multiple branches of reality arising from quantum events within our universe, but a broader concept that suggests our entire universe, with all its physical laws, constants, and dimensions, is just one of many. Several different approaches to theoretical physics independently suggest the existence of multiple universes. Inflation, our best theory for the universe's early exponential expansion, naturally produces an eternal inflationary multiverse, where new bubble universes are constantly nucleating within an ever-expanding cosmic medium. String theory suggests a landscape of possible vacuum states, different configurations of the underlying theory that would manifest as universes with different physical laws, different constants, different numbers of dimensions. With 10 to 500 or more possible vacuum states, the string theory landscape offers an unimaginably vast multiverse of possibilities. Cosmological natural selection, proposed by physicist Lee Smolin, suggests a kind of cosmic Darwinism, where universes that produce more black holes have more offspring universes, leading to an evolutionary process that shapes the physical laws we observe. These aren't competing Theories so much as different aspects of a larger picture, different ways of understanding how our universe relates to a potentially infinite set of alternate realities. What would these other universes be like? Some might have different values for the fundamental constants, the strength of gravity, the mass of the electron, the strength of the nuclear forces. Others might have different symmetries, different forces, different particles. Some might have more dimensions or fewer. Some might operate according to physical laws so different from ours that we can barely conceptualize them. Most of these universes would likely be sterile, unable to support complex structures like stars, planets, or life. A universe where gravity is slightly stronger, for instance, would form only short-lived stars that burn out before planets can form. A universe where electromagnetism is significantly weaker would have atoms that easily fall apart. A universe where the nuclear forces have different values might not form stable elements at all. Our universe, with its particular set of physical laws and constants, appears finely tuned for complexity, set within narrow ranges that allow for stars, planets, chemistry, life. This apparent fine-tuning has traditionally been viewed as either evidence for design or an extraordinary cosmic coincidence. But the multiverse offers a third explanation. If there are countless universes with different properties, it's inevitable that some will happen to have the right properties for complexity, and equally inevitable that conscious observers will find themselves in those rare universes capable of supporting their existence. This anthropic reasoning doesn't tell us why a multiverse should exist in the first place, or why it should generate universes with varying physical laws. It pushes the question back a level. Instead of asking why our universe is fine-tuned for complexity, we ask why reality generates a multiverse that includes universes like ours. But perhaps that's a more answerable question. Perhaps the principles that give rise to a multiverse are simpler, more fundamental, more mathematically elegant than the principles that would give rise to a single, finely tuned universe. Perhaps, as the physicist Max Tegmark suggests, all mathematically possible universes actually exist, and ours is simply one among that infinite set. This mathematical universe hypothesis proposes that reality isn't just described by mathematics. It is mathematics. Physical reality is a mathematical structure, and our universe is simply one particular solution to the equations that govern existence. If true, this would explain what physicist Eugene Wigner called the unreasonable effectiveness of mathematics. In the natural sciences, the astonishing fact that the universe obeys mathematical laws we can discover and understand. It's effective because the universe isn't just mathematically describable, it's fundamentally mathematical in nature. But this raises profound questions about the nature of mathematics itself. Is mathematics invented or discovered? If all mathematically possible structures exist as universes, does that mean mathematical truth is the same as physical existence? And what about consciousness? How does awareness arise from mathematical structures? These questions lead us to the frontier of reality's edge, where physics, mathematics, information theory, and philosophy converge. They suggest that our quest to understand the cosmos isn't just about mapping the physical universe, but understanding the deeper principles from which physical reality emerges. And this brings us to perhaps the most radical theory of all: reality as a simulation. The idea that what we experience as physical reality might be a sophisticated computation, a simulation running on some substrate beyond our direct observation, has moved from science fiction to serious scientific and philosophical discourse. The simulation hypothesis doesn't claim we're in a computer program like those we create today. It suggests that sufficiently advanced civilizations, perhaps our own descendants in the far future, might create simulated realities so sophisticated that the conscious entities within them would have no way of knowing they're in a simulation. If we accept that such simulations are possible in principle, and if we accept that a civilization could create many such simulations, then probabilistically speaking, most conscious experiences would occur within simulations rather than base reality. Like inhabitants of Plato's cave, we might be experiencing mere shadows of a deeper reality, not projected on a cave wall, but computed in whatever substrate hosts the simulation. This isn't as untestable as it might seem. A simulated reality might contain subtle glitches or optimizations, signs that what we experience isn't fundamental but constructed. Some physicists have suggested that the quantization of spacetime, the seemingly arbitrary values of physical constants, or the wave-particle duality of quantum mechanics might be such signs, features that make more sense as computational shortcuts than as fundamental aspects of reality. But the simulation hypothesis raises its own profound questions. What would it mean if reality is computed? Does that make it less real? And what about the simulators? Are they in base reality, or are they themselves simulated in a higher-level simulation, creating a potentially infinite regress? Perhaps more importantly, what would constitute evidence for or against this hypothesis? What observations could potentially distinguish between a fundamental reality and a simulated one? These questions remain open at the frontier of our exploration of reality's edge. Let's shift our focus to another enigmatic aspect of our universe: dark energy and its implications for the fate of everything. We've established that dark energy, that mysterious repulsive force accelerating the expansion of the universe, constitutes about 68% of the total energy content of the cosmos. But what is it? And what does it mean for our cosmic future? One possibility is that dark energy is a property of empty space itself, a cosmological constant embedded in the fabric of space-time. This would mean that every cubic meter of empty space contains a fixed amount of dark energy, an intrinsic tension that pushes space apart. But the value of this energy poses a profound puzzle. Quantum field theory attempts to calculate the energy of the vacuum from first principles and gets an answer that's off by 120 orders of magnitude. This has been called the worst theoretical prediction in the history of physics. Why should the cosmological constant have the precise tiny value we observe rather than the enormously larger value theory predicts? Another possibility is that dark energy isn't constant but dynamic, a field that changes over time, perhaps oscillating between attractive and repulsive phases. This quintessence model suggests the universe might eventually stop accelerating and begin contracting again, leading to a big crunch rather than endless expansion. A third, more radical possibility is that dark energy reflects a fundamental misunderstanding in our theory of gravity. Perhaps Einstein's general relativity, for all its confirmed predictions, is incomplete on the largest scales. Perhaps what we interpret as an accelerating expansion is actually a sign that gravity works differently at cosmic distances. Modified. Gravity theories, from FR gravity to massive gravity to brane-world models, suggest various ways that Einstein's equations might need revision. These aren't just ad hoc adjustments, but attempts to derive general relativity as a special case of more fundamental principles. But for now, dark energy remains a mystery, a force we can measure but cannot explain, a presence that dominates the energy budget of the universe yet eludes our theoretical understanding. And this mystery has profound implications for the fate of the cosmos. If dark energy remains constant, the universe will continue to expand at an accelerating rate. Galaxies beyond our local group will recede beyond our cosmic horizon, their Light stretched to invisibility by the expanding space between us. Eventually, even neighboring galaxies will vanish from view. In the far future, observers would see only their own galaxy in an otherwise empty universe, all evidence of the broader cosmos having disappeared beyond a darkened horizon. Over even longer timescales, trillions upon trillions of years, stars will burn out, black holes will evaporate, and matter itself may decay. The universe would approach a state of maximum entropy, a nearly empty void, with elementary particles separated by unimaginable distances, occasionally interacting through quantum fluctuations. This heat-death scenario represents a kind of cosmic finality, not an end of time, but an end of change, an end of complexity, an end of anything we would recognize as structure or life. But this is only one possible fate. If dark energy is dynamic rather than constant, the universe's expansion might eventually slow and reverse. Galaxies would begin to approach each other, space would contract, temperatures would rise. Eventually, the entire universe would collapse into a state of extreme density and temperature, a big crunch that, in some theories, might give rise to a new Big Bang, initiating another cycle of cosmic evolution. This cyclic model suggests a universe that oscillates between expansion and contraction, between cooling and heating, between complexity and simplicity. A cosmic heartbeat pulsing through eternity. A third possibility emerges from vacuum decay scenarios. Quantum field theory suggests that our universe might exist in a false vacuum state, a local minimum of energy that appears stable but isn't the lowest possible energy state. If true, a quantum fluctuation could trigger a transition to a lower energy state, a vacuum decay that would propagate outward at the speed of light, transforming the very fabric of reality in its wake. From within our current vacuum, we can't know what physics would operate in this lower energy state. The fundamental constants might change, the forces might operate differently. The very particles that constitute our reality might cease to exist or transform into something unrecognizable. It would be, in a very real sense, the end of our universe and the birth of another, not in sequence, but through a phase transition that rewrites the laws of physics themselves. These scenarios, heat death, cyclic rebirth, vacuum decay, represent radically different cosmic futures. Each emerges from our current understanding of physics, each carries its own philosophical implications, and each remains speculative, dependent on properties of dark energy and quantum fields that we haven't yet measured precisely. But they all share a common theme. The universe as we know it, with its galaxies and stars, its planets and life forms, its complexity and consciousness, represents a transient state in a much longer cosmic story. Whether that story ends in eternal stasis, endless cycles, or radical transformation, our current cosmic era is but a chapter, not the full narrative. This realization that our universe has a history and a future, that it undergoes phases and transitions, that it isn't static or unchanging but dynamic and evolving, transforms our relationship with the cosmos. We aren't living in a finished creation, but in a universe still in process, still unfolding, still becoming what it will be. And our consciousness, our ability to perceive, to think, to wonder about these mysteries, may itself be part of that unfolding, not separate from the cosmic process, but an aspect of it, a way that matter has organized itself to contemplate its own existence and possible futures. Let's now turn our attention to an even more enigmatic aspect of reality. Black holes, where space and time are stretched to their limits, where quantum mechanics and general relativity collide, where our understanding of physics faces its greatest challenge. A black hole forms when matter collapses under its own gravitational pull, creating a region of spacetime so severely curved that nothing, not even light, can escape once it crosses the event horizon. At the center of this region, according to classical general relativity, lies a singularity, a point of infinite density and zero volume, where spacetime curvature becomes infinite. But as we've discussed, quantum effects likely prevent true singularities from forming. The actual core of a black hole may be something more complex, a region of extreme but finite density, perhaps a tangle of strings in string theory, or a network of quantum loops in loop quantum gravity, or a configuration of quantum information, with properties we're still working to understand. The event horizon surrounding this core presents its own profound mysteries. It's not a physical boundary, but a point of no return, a region where the curvature of space-time becomes so extreme that all future paths lead inexorably inward. Cross that boundary, and the direction that was once toward the black hole becomes toward the future. Your fate isn't just likely, but geometrically guaranteed. This guarantee creates paradoxes. What happens to the information contained in matter that falls into a black hole? Quantum mechanics requires that information can never be truly destroyed. That if you knew the exact state of every particle in a system, you could in principle reverse engineer its prior states. But once matter crosses the event horizon, seems that this information becomes irretrievably lost, at least from the perspective of outside observers. Or does it? In the 1970s, Stephen Hawking made the revolutionary discovery that black holes aren't entirely black. They emit a faint radiation due to quantum effects near the event horizon. This Hawking radiation causes black holes to slowly lose mass and eventually evaporate completely. But this creates a deeper paradox. When the black hole evaporates, what happens to the information that fell into it? If it's truly lost, then quantum mechanics is violated. If it's preserved in the Hawking radiation, then how does it escape from behind the event horizon? This black hole information paradox has driven theoretical physics for decades, leading to profound insights and radical proposals. Some suggest that information never actually crosses the event horizon, but is preserved in a holographic form on the horizon itself. Others propose that information gradually leaks out with the Hawking radiation through subtle quantum correlations. Still others suggest more radical solutions, that black holes create baby universes, that they tunnel to white holes, that expel their contents in another region of spacetime, or that they connect to other universes through traversable wormholes. These aren't just speculative fantasies. They emerge from serious attempts to reconcile quantum mechanics and general relativity in the extreme conditions of black holes. And they highlight the profound connection between information, gravity, and the fabric of spacetime itself. One of the most profound insights to emerge from this research is the holographic principle, the idea that the information contained in a region of space can be represented by information on the boundary of that region. In the context of black holes, this suggests that everything that falls into a black hole is encoded on its event horizon, not just recorded there, but fundamentally equivalent to it, in the same way that a hologram encodes three-dimensional information on a two-dimensional surface. This principle has been generalized to suggest that our entire universe may be holographic, that the three-dimensional reality we experience may be mathematically equivalent to a two-dimensional information structure on some distant boundary. Our experience of depth, of space extending in three dimensions, may be a kind of illusion, not because space isn't real, but because it's emergent from something more fundamental, something that exists in fewer dimensions. If true, this would mean that space itself, the arena in which everything seems to happen, may be a kind of projection, a way of organizing information that exists in a more fundamental, non-spatial form. The three dimensions we experience may be a useful approximation, a way for our minds to organize and understand patterns that exist in a deeper reality with different fundamental properties. This isn't to say that space isn't real. It's real. In the same way that temperature is real, it's a property that emerges at certain scales and under certain conditions, a useful way of describing collective behavior that doesn't apply at more fundamental levels. But the holographic principle suggests something deeper. That information, not matter or energy, may be the fundamental currency of reality. That what exists are not particles or waves, but relationships, patterns of correlation between events. Reality emerges from the way these correlations are structured, not from the physical substrate that embodies them. This information-theoretic view of reality has profound implications. It suggests that the laws of physics may be, at their core, laws of information, rules governing how patterns can change and evolve. The conservation of energy, the invariance of the speed of light, the uncertainty principle. These may all be theorems in a deeper informational framework, not fundamental postulates. It also suggests a profound connection between information, gravity, and entropy. The physicist Eric Verlinde has proposed that gravity isn't a fundamental force, but an emergent phenomenon, a consequence of the tendency of entropy to increase. In this view, gravity emerges from the statistical behavior of microscopic degrees of freedom, just as temperature emerges from the statistical behavior of molecules. Entropy, the measure of a system's disorder, or, more precisely, the number of possible microscopic states consistent with its macroscopic properties, plays a crucial role in these theories. The second law of thermodynamics, which states that the entropy of an isolated system never decreases, may be more than just a useful principle. It may be a fundamental constraint on how information can be organized and processed in our universe. Feed. Entropy of black holes, in particular, has provided key insights. The entropy of a black hole is proportional not to its volume, as one might expect, but to its surface area, specifically the area of its event horizon. This unexpected scaling suggests that the information content of a region of space may be limited not by its volume, but by its boundary area, a direct implication of the holographic principle. This boundary area limit on information may apply not just to black holes, but to any region of space. It suggests a kind of cosmic information budget, a finite capacity for storing and processing the patterns that constitute reality as we experience it. If true, this informational approach may help resolve some of the paradoxes we've encountered. The apparent loss of information in black holes may be an illusion arising from our view of space as fundamental rather than emergent. The conflict between quantum mechanics and general relativity may reflect our attempt to reconcile theories at different levels of description, rather than a fundamental incompatibility. Even the mystery of dark energy may take on a new character. In this light, if spacetime itself is emergent from an underlying information structure, then dark energy, the apparent intrinsic tension of empty space, may reflect properties of that deeper reality, rather than an unexplained cosmological constant. These information-theoretic approaches remain speculative at the frontier of theoretical physics, but they represent a profound shift in how we think about reality, from a focus on substance, matter and energy, to a focus on pattern, information and relationship. From a universe of things to a universe of information. And this brings us to perhaps the most profound mystery of all, the nature of consciousness and its place in the cosmic scheme. We began this journey exploring the edge of reality, the limits of our understanding of the physical universe. But consciousness itself, the awareness that allows us to undertake this exploration, remains perhaps the greatest mystery of all. How does awareness arise from physical processes? How does subjective experience, the felt quality of seeing, blue, hearing Mozart, tasting chocolate, emerge from neurons firing in the brain? This hard problem of consciousness, as philosopher David Chalmers termed it, may represent another edge of reality, a boundary not of cosmic scale, but of the relationship between mind and matter. Some physicists have proposed that consciousness may be more fundamental than it appears, not an epiphenomenon of brain activity, but a basic aspect of reality, perhaps connected to quantum processes or information states. The physicist Roger Penrose and anesthesiologist Stuart Hameroff have suggested that quantum coherence in brain microtubules might play a role in generating consciousness. Others, like the physicist John Wheeler, have proposed that observation, which inevitably involves consciousness, plays a fundamental role in collapsing quantum possibilities into definite realities. Wheeler's memorable phrase, "it from bit," suggests that information, bit, is more fundamental than substance, it, that the physical world emerges from information, not the other way around. In this view, consciousness, which processes and interprets information, may be not just an observer of reality, but a participant in its creation. This isn't to suggest a naive form of idealism, that reality exists only in our minds. Rather, it suggests a more subtle relationship between mind and matter, between observer and observed, between consciousness and the physical world. A relationship in which the distinction between subject and object may not be as fundamental as we've assumed. We've ventured far into the theoretical frontiers of physics, exploring the boundaries where our understanding begins to fray. But now, let's shift our perspective. Let's stop viewing these cosmic mysteries as abstract puzzles and consider what they mean for us, for you, as a conscious being adrift in this unfathomable universe. Look down at your hands for a moment. Examine the lines on your palm, the subtle movements of your fingers, the color of your skin in this light. These hands that you call yours, what are they, really? According to physics, they're collections of atoms, themselves made of subatomic particles, which may ultimately be vibrations, in quantum fields or strings in hidden dimensions. But those atoms aren't the same ones you were born with. Your body has replaced nearly every atom over the years, rebuilding itself continuously like a city that tears down and reconstructs its buildings while its inhabitants continue their daily lives, unaware of the wholesale transformation happening beneath them. You are not the same physical entity you were a decade ago. Not a single atom remains. Yet you feel continuous, persistent, the same you, despite this complete material replacement. What does this tell us about identity? About the relationship between consciousness and its physical substrate? If you're not your atoms, what are you? Perhaps you're a pattern, a specific organization of information that persists even as its physical embodiment changes. Like a wave traveling across the ocean, maintaining its form while the water molecules that constitute it are constantly replaced. The wave isn't the water. It's a pattern moving through the water. Perhaps you aren't your atoms. You're a pattern, moving through atoms. But this pattern-based identity raises unsettling questions. If consciousness is a pattern of information, could it be replicated, transferred? Could the specific configuration of information that constitutes you exist in multiple places, in multiple substrates? If your exact neural pattern were duplicated in another brain or simulated in a computer, would that be you too? Would it have the same claim to your identity, your memories, your sense of self? And what happens to this pattern when your body dies? Does the information disperse, like a wave breaking on the shore? Or is it preserved somehow in the deeper informational structure of reality? Not as a soul in any traditional religious sense, but as a configuration of data that leaves its mark on the cosmic information field. These aren't just philosophical speculations. They emerge directly from our best understanding of physics, from the realization that information may be more fundamental than matter, that patterns may be more primary than particles. Now let's pull back further, from your body to your timeline. The life you've lived, from your earliest memories to this present moment. Reading these words, you experience it as a sequence, a linear progression from past to future. But we've seen that time itself may not be fundamental, that the flowing time we experience may be an emergent property, a useful approximation that breaks down at the deepest levels of reality. If time is an illusion, then everything you've ever done, your first steps, your greatest triumphs, your deepest regrets, might exist timelessly, permanently etched into the cosmic structure, not happened in the past tense, but simply existing in a space-time manifold that encompasses all events at once. Your birth, your death, this present moment, all equally real, all equally now, from the perspective of the timeless whole. This isn't just a philosophical curiosity. It transforms how we understand existence itself. The child you once were isn't gone, lost to the past. They exist in their proper region of space-time, as real as you are now. The person you will become already exists in their future region, already experiencing whatever joys and sorrows await. From the timeless perspective, your life isn't happening. It simply is, complete and whole, a four-dimensional sculpture in the gallery of existence. Does this mean your future is predetermined? That free will is an illusion? Not necessarily. Even in a timeless reality, your choices may matter, not because they change a future that doesn't yet exist, but because they constitute who you are in the totality of your existence. Your choice in this moment isn't changing the future. It's determining which timeless you exists at all. And what if the many worlds interpretation of quantum mechanics is correct? What if reality branches with every quantum event, creating parallel versions of you living out every possible variation of your life? Then somewhere, in some branch of reality, you made a different choice at every crossroads. Somewhere you pursued that abandoned dream. Somewhere you spoke those unsaid words. Somewhere you took that road not taken. Are these parallel versions of you any less real than the version reading these words? Are they any less entitled to be called you? Or are they equally valid expressions of your existence, alternate manifestations of the same underlying pattern? If this seems abstract, consider. The atoms in your body were forged in the hearts of dying stars billions of years ago. The carbon in your cells, the oxygen in your blood, the calcium in your bones, all created in stellar furnaces that exploded and scattered their contents across the cosmos long before our solar system formed. As astronomer Carl Sagan famously said, "We are made of star stuff." But that connection goes deeper than mere material origin. The laws that govern those stars, the fundamental forces, the conservation principles, the mathematical symmetries, are the same laws that govern your body, your brain, your thoughts. You aren't just made of star stuff. You operate according to the same principles. You're governed by the same mathematics. You're an expression of the same underlying reality. This isn't poetic metaphor. It's physical fact. The cosmos isn't out there, separate from you. You are the cosmos, a particular configuration of it, a specific pattern of its energy and information, a unique perspective from which the universe experiences itself. And yet, despite this profound connection, The scale of the cosmos dwarfs us to insignificance. Look up at the night sky. Each point of light is a sun, many larger and more powerful than our own. Between those visible stars are billions more too faint to see, and beyond them, billions of galaxies, each containing billions of stars. The Recursive observable universe spans approximately 93 billion light-years in diameter. Light from the most distant visible regions has traveled for 13.8 billion years to reach your eyes. In that vast expanse exist hundreds of billions of galaxies, each containing hundreds of billions of stars, many orbited by planets, some perhaps harboring life. If our entire solar system were shrunk to the size of a grain of sand, the Milky Way galaxy would span an area larger than California. And the Milky Way is just one galaxy among billions in the observable universe, which itself may be a tiny fraction of the total cosmos beyond our cosmic horizon. The scales are impossible to truly comprehend. If the Earth were a marble, Jupiter would be the size of a basketball, and the Sun would be a sphere 4 meters in diameter. At that scale, the nearest star, Proxima Centauri, would be 6,500 kilometers away, roughly the distance from New York to Rome. But even these analogies fail to capture the true vastness, the emptiness between stars, between galaxies, between cosmic filaments. The sheer, yawning void that constitutes most of the universe exceeds our ability to intuitively grasp. Look again at your hands. Consider that in the vastness of cosmic space, you are smaller than a bacterium on a grain of sand in the Sahara. In the vastness of cosmic time, your entire life is briefer than the flash of a firefly. From a purely physical perspective, you are utterly insignificant, a momentary arrangement of atoms in an inconceivably vast cosmos. And yet, you are aware. You can contemplate the stars, understand the equations that describe their behavior, wonder about your place in the cosmic scheme. This awareness, this consciousness that allows you to read these words and contemplate their meaning, remains perhaps the greatest mystery of all. How does matter organize itself to become aware? How does the universe give rise to parts that can contemplate the whole? These questions lie at the frontier of scientific inquiry, at the boundary where physics meets philosophy. Some scientists, like physicist Roger Penrose, suggest that consciousness may involve quantum processes, that the coherent quantum states in neural microtubules might play a role in generating awareness. Others propose that consciousness emerges from the complex information processing of neural networks, with no need for quantum effects. But perhaps a more profound possibility lurks behind these theories. What if consciousness isn't produced by matter, but is a fundamental aspect of reality itself? What if awareness, like space and time, emerges from something deeper, something intrinsic to existence? The philosopher Philip Goff proposes panpsychism, the idea that consciousness may be a fundamental feature of all physical entities, from electrons to galaxies. Not that electrons think or feel as we do, but that they possess some rudimentary form of subjectivity, some minimal inner experience that, when organized in the right complexity, gives rise to the rich consciousness we humans experience. This isn't mere mysticism. It emerges from the hard problem of consciousness, the challenge of explaining how physical processes, no matter how complex, could give rise to subjective experience. If consciousness isn't somehow built into the fundamental nature of reality, how does it arise from elements that supposedly lack it entirely? The physicist John Wheeler proposed something even more radical, that the universe is a self-excited circuit, a participatory reality that requires observers to bring it into existence. In his view, quantum mechanics suggests that observation plays a role in determining reality, that the act of measurement doesn't just reveal pre-existing properties, but helps define them. If Wheeler is right, if observation truly plays a role in determining reality, then consciousness isn't just an epiphenomenon, a byproduct of physical complexity. It's an active participant in the cosmic process, a factor in the unfolding of reality itself. What if the universe is alive, and we are just its fleeting thoughts? This isn't as far-fetched as it might seem. Consider, the universe contains conscious beings, like you, who are made of its substance, governed by its laws, expressions of its nature. Through you, through all conscious entities, the universe experiences itself, observes itself, contemplates itself. In you, the cosmos has evolved a way to witness its own existence, to reflect on its own nature. From stardust to planets, from molecules to cells, from neurons to consciousness, the universe has organized itself into entities that can observe and understand it. Is this merely an accident, a side effect of blind physical processes? Or is it something more profound, a manifestation of the cosmos's intrinsic tendency toward complexity, awareness, self-knowledge? What if consciousness doesn't require brains? What if brains are just one particular physical system that can sustain and express consciousness, but not the only one? What if awareness can exist in other substrates, other configurations, at other scales? Could a galaxy be conscious? Not with a brain or neural network, obviously, but in some other way, through the complex interactions of its stars, its black holes, its dark matter. Could the entire universe possess a form of awareness utterly different from human consciousness, yet still recognizable as subjectivity, as experience? These questions may seem too speculative for science, too mystical for serious consideration, but they emerge naturally from our journey to the edge of reality, from our exploration of the profound mysteries of existence. And they highlight a critical point. Consciousness isn't just another scientific puzzle to be solved, but a fundamental aspect of our cosmic situation. Perhaps the most direct connection we have to the mystery of being itself. Because here's the astonishing thing: whatever the universe is, whatever reality ultimately consists of, you are that. Not in some abstract philosophical sense, but in the most concrete, physical, actual way. You are not in the universe. You are the universe, a particular configuration of it, a specific pattern of its energy and information, experiencing itself from a unique perspective. And that perspective is incredibly limited. Your senses detect only a tiny fraction of the electromagnetic spectrum. Your brain evolved to navigate a medium-sized world at medium speeds, not to intuitively grasp quantum superposition or relativistic time dilation. Your conscious awareness can track only a few objects simultaneously, can consider only a small number of options, can imagine only a limited set of possibilities. Yet through science, mathematics, technology, and collective intelligence, you've transcended these limitations. You've built instruments that detect cosmic radiation invisible to your eyes. You've developed mathematics that describes realms beyond direct perception. You've created theories that explain phenomena your ancestors couldn't have dreamed of. In a very real sense, human civilization represents the universe's attempt to understand itself, using patterns of matter called brains, symbols called language, tools called instruments, methods called science. Through these means, the cosmos has evolved a way to contemplate its own existence, to map its own structure, to probe its own nature. But this collective effort has led us to a precipice, to the realization that reality may be far stranger, far more alien to our intuitions, far more profound than we initially supposed. That space and time themselves may be emergent rather than fundamental, that what we experience as reality may be a holographic projection of a deeper information structure, that consciousness may be woven into the very fabric of existence. These aren't just abstract scientific theories. They're existential revelations that transform our understanding of what it means to be.
Bečtěje, teď můžeme to devenmoris. Springen stenabolovatoli dogis nina tiptin. Sådant trott jag inte vol för vår svivoteladen popo vidibilitesites.
Fundamentally is, imagine a fish that has never left water trying to understand the concept of dryness. No matter how intelligent the fish, no matter how sophisticated its science, the direct experience of dryness would remain beyond its reach as long as it remained in water. Similarly, we may be trapped in our particular mode of consciousness, unable to directly experience the ultimate nature of reality, even as we develop ever more sophisticated theories about it. This isn't cause for despair, but for wonder. The mystery isn't a wall, but a doorway, not a limitation, but an invitation. The realization that reality transcends our cognitive grasp doesn't diminish us. It enlarges us, connecting us to something greater than the bounded self, something more fundamental than the apparent world. But this connection comes with vertigo. The scales involved, both of cosmic space and of fundamental reality, are disorienting, unsettling, awesome in the original sense of that word. Inspiring fear mingled with wonder. Consider this. In the vast expanse of cosmic space and time, everything human, our entire species, our civilization, our planet, our solar system, is less than a dust mote, less than the period at the end of this sentence. And if the multiverse theories are correct, our entire observable universe is just one bubble in a vast, perhaps infinite cosmic foam. In that context, your individual life is smaller than an atom, briefer than a quantum fluctuation. And yet, you are aware. You can contemplate the stars, understand the equations, wonder about your place. This awareness, this consciousness that lets you read these words and ponder their meaning, remains the most direct connection you have to the mystery at the heart of existence, because that's the paradox of human existence. We are simultaneously insignificant and profound, physically tiny, yet mentally vast. Brief moments in cosmic time, yet capable of comprehending billions of years. Made of ordinary matter, yet able to contemplate the extraordinary nature of reality itself. In your most honest moments, you've probably felt this paradox, the strange dual nature of consciousness, at once intimately personal and cosmically connected. The sense that you are both a limited, temporary being and an expression of something much larger, much more fundamental. This isn't mysticism, but phenomenology, an accurate description of what it feels like to be human, to be a conscious entity in this vast universe. It's the recognition that your awareness, your subjective experience, isn't just a useful evolutionary adaptation, but a profound cosmic mystery. Because here's something truly strange. The universe has evolved parts that can contemplate the whole, through you, through all conscious entities. The cosmos experiences itself, observes itself, reflects on itself. Is this merely an accident? A side effect of blind physical processes? Or is it something more significant? A manifestation of the universe's intrinsic tendency toward complexity, awareness, self-knowledge. What if consciousness isn't a random byproduct, but an essential aspect of cosmic evolution? What if awareness, like complexity, emerges naturally as the universe unfolds? Not because it was designed to do so by some external creator, but because it's a fundamental potentiality of existence itself, a latent capacity of matter and energy when organized. In certain ways, this perspective doesn't require spirituality or supernaturalism. It emerges naturally from a clear-eyed assessment of our cosmic situation, from the recognition that consciousness is not separate from nature, but a manifestation of it. Not alien to the cosmos, but expressions of it. But this realization comes with existential weight. If you are the universe experiencing itself from a particular perspective, what responsibility does that entail? If consciousness is a fundamental aspect of cosmic evolution, what is its purpose, its role, its significance? These questions cannot be answered by physics alone. They require a broader inquiry, a synthesis of science, philosophy, and lived experience. They call us to consider not just what the universe is, but what it means, not just how it functions, but why it matters. And here we encounter perhaps the most profound mystery of all: meaning itself. In a universe governed by physical laws, where particles and fields interact according to mathematical rules, how does meaning arise? How do values emerge? How does purpose manifest? From one perspective, the universe simply is a vast, complex system evolving according to impersonal principles, neither meaningful nor meaningless, neither caring nor indifferent, simply existing in its intricate, awesome totality. Yet within that system, meaning undeniably emerges. You experience value, purpose, significance. You feel the weight of ethical choice, the call of beauty, the desire for understanding. Are these merely subjective projections, useful illusions evolved to guide behavior? Or do they reflect something more fundamental about the nature of reality itself? What if meaning isn't something we project onto an indifferent universe, but something we recognize within it? What if values aren't arbitrary constructs, but discoveries, recognitions of patterns that exist in the nature of consciousness itself? This perspective suggests that the emergence of consciousness in the universe isn't just a curious phenomenon, but a profound development. The cosmos evolving the capacity to experience itself, to value itself, to find meaning within itself, not through external design, but through internal unfolding, through the natural emergence of complexity, awareness, understanding. And if that's true, then your consciousness isn't just a private experience, but a cosmic event, a manifestation of the universe's intrinsic potential for awareness, for meaning, for significance. This doesn't solve the mystery, it deepens it. It doesn't answer the ultimate questions, but reveals their profound importance. It suggests that your search for meaning isn't separate from the cosmic process, but an aspect of it, not alien to the universe, but an expression of its evolving nature. Consider this: the same cosmos that produced stars and galaxies produced the consciousness reading these words. The same fundamental laws that govern the motions of planets govern the thoughts in your mind. The same evolutionary process that shaped life on Earth shaped the awareness experiencing this moment. You aren't apart from this process, but a part of it. Not a stranger in an alien universe, but a manifestation of the cosmos itself, experiencing its own existence from a unique perspective. Your consciousness isn't just in the universe, it's of the universe, a way that reality has evolved to witness itself, to know itself, to reflect on its own nature. This isn't a comfortable realization. It comes with existential vertigo, with the disorienting awareness that you are simultaneously tiny and vast, temporary and connected to something much more enduring. It means recognizing that your ordinary perception of reality, the world of solid objects, linear time, clear cause and effect, may be a useful interface rather than ultimate truth. But this realization also comes with profound potential. The possibility of experiencing your connection to the whole, of recognizing your intimate relationship with the cosmic process, of understanding yourself not as a separate entity, but as a manifestation of something much larger and more significant. Imagine time as a vast landscape, not flowing, but simply existing in its totality. Your life, from birth to death, is a path through that landscape, a specific trajectory through the terrain of possibility. From within the path, you experience each moment as now, each previous segment as past, each upcoming segment as future. But what if you could somehow step outside that path, view the entire landscape at once? What if you could see your whole life not as a sequence, but as a shape, a pattern in the fabric of space-time? From that perspective, nothing would be lost to the past or hidden in the future. Your entire existence would be equally real, equally present, equally now. This isn't just a thought experiment. It emerges directly from our best understanding of physics, from the block universe model implied by relativity. If time is a dimension rather than a flow, then your entire life exists timelessly, permanently etched into the cosmic structure. What would it mean to truly understand this? Not just intellectually, but experientially. How would it transform your relationship with time, with mortality, with the apparent transience of existence? From one perspective, it's terrifying, suggesting a kind of determinism, a fixed trajectory with no possibility of deviation. But from another, it's profoundly liberating, suggesting that nothing is ever truly lost, that the people you've loved who are gone from your present remain real in their proper region of space-time, that the child you once were still exists, that the person you will become already experiences whatever awaits. And what if the many worlds interpretation is correct? What if reality branches with every quantum event, creating parallel versions of you living out every possible variation of your life? Then somewhere, in some branch of reality, you made a different choice at every crossroads. Imagine that, not as abstract theory, but as concrete reality. Somewhere, right now, whatever now means in this context, another version of you is reading slightly different words. Somewhere else, you never encountered this text at all. Somewhere you pursued that abandoned dream. Somewhere you spoke those unsaid words. Somewhere you took that road not taken. Are these parallel versions of you any less real than the version reading these words? Are they any less entitled to be called you? Or are they equally valid expressions of your existence, alternate manifestations of the same underlying pattern? This multiplicity doesn't diminish your individual experience. It enriches it, connecting your particular path to an infinite tapestry of possibility, your specific choices to the full spectrum of potential. But these cosmic perspectives, the timeless block universe, the branching multiverse, can feel cold, abstract, divorced from the warm immediacy of lived experience. How do we bridge this gap? How do we integrate these profound cosmic insights with the intimate reality of being human? Perhaps through a recognition that consciousness itself is the bridge, that your awareness, your experience, your subjective being is both intimately personal and cosmically connected, that you are simultaneously a specific, limited perspective and an expression of something much larger, much more fundamental. This recognition doesn't solve the ultimate mysteries. It doesn't tell us why the universe exists at all, why reality takes the particular form it does, why consciousness emerged within it. But it changes our relationship with these questions, transforming them from abstract puzzles into lived inquiries, from theoretical concerns into existential explorations. Because here's the crux: the same consciousness that allows you to read these words, to ponder these mysteries, to feel these emotions, is your direct connection to the fundamental nature of reality. Not a separate thing looking in from outside, but an aspect of the whole experiencing itself from within. This doesn't mean that your individual consciousness is identical to the universe as a whole. That would be a simplistic misunderstanding. It means that your awareness, your experience, your subjective being is a manifestation of whatever reality fundamentally is, a pattern within the cosmic fabric, a perspective within the infinite potential of existence, and this realization has profound implications for how we understand meaning, purpose, value. If consciousness isn't just a random byproduct but an essential aspect of cosmic evolution, then the meanings we discover, the values we recognize, the purposes we pursue may reflect something fundamental about the nature of reality itself, not because they were designed into the cosmos by some external creator, but because they emerge naturally from what the universe is, from its intrinsic tendency toward complexity, awareness, understanding. This perspective doesn't require spirituality or supernaturalism. It emerges naturally from a clear-eyed assessment of our cosmic situation, from the recognition that consciousness is not separate from nature, but a manifestation of it, not alien to the universe, but an expression of it. But this view does transform our understanding of what it means to be human, to be conscious, to be. It suggests that our search for meaning, our recognition of value, our pursuit of understanding aren't merely subjective projections, but discoveries, recognitions of patterns that exist in the nature of consciousness itself, in the fabric of reality as it manifests through awareness. And if that's true, then your consciousness isn't just a private experience, but a cosmic event, a manifestation of the universe's intrinsic potential for awareness, for meaning, for significance. This doesn't solve the mystery, it deepens it. It doesn't answer the ultimate questions, but reveals their profound importance. It suggests that your search for meaning isn't separate from the cosmic process, but an aspect of it, not alien to the universe, but an expression of its evolving nature. But let's pull back from these speculative frontiers and return to a more immediate truth. You exist. Whatever reality ultimately is, however consciousness relates to the physical world, whatever meaning signifies, this much is certain. You are here, now, experiencing this moment, pondering these mysteries. And that fact itself is perhaps the most astonishing feature of our cosmic situation. In a universe of such vast scales, such profound complexity, such unfathomable strangeness, awareness has emerged. Through billions of years of cosmic evolution, through countless steps of increasing complexity, through processes we're only beginning to understand, consciousness has arisen. Not as something separate from the cosmos, but as an aspect of it, a manifestation of its intrinsic potential, a way that reality has evolved to experience itself from within. This isn't mysticism, but empirical fact. You exist, you are aware, you experience. And that awareness, that experience, is not separate from the cosmic process, but an expression of it, not alien to the universe, but a manifestation of its evolving nature. In you, in all conscious entities, the cosmos has developed the capacity to witness its own existence, to reflect on its own nature, to wonder about its own meaning. Through you, the universe questions itself, explores itself, experiences itself. Is this merely an accident, a side effect of blind physical processes? Or is it something more significant, a manifestation of the universe's intrinsic tendency toward complexity, awareness, self-knowledge? The answer isn't written in the stars or encoded in the laws of physics. It emerges from how we relate to our cosmic situation, from the meaning we recognize in our conscious experience, from the values we discover through our awareness, and perhaps that's the most profound mystery of all, that the universe has evolved parts that can contemplate the whole, beings that can question their own existence, consciousness that can reflect on its own nature. In the vast cosmic darkness, awareness has kindled. In the cold equations of physics, meaning has emerged. In the impersonal processes of evolution, personhood has developed, not through external design but through internal unfolding, through the natural emergence of complexity, consciousness, understanding, and you are part of this emergence, not a passive observer but an active participant, not separate from the cosmic process but an expression of it. Your awareness, your experience, your subjective being is a manifestation of whatever reality fundamentally is, a pattern within the cosmic fabric, a perspective within the infinite potential of existence. This doesn't mean your individual consciousness is eternal or that your personal identity transcends death. The pattern that constitutes you may disperse when your body dies, like a wave breaking on the shore. But the deeper reality from which that pattern emerged, the fundamental nature of existence that manifests as consciousness, remains, not as a personal God or a cosmic mind, but as the intrinsic potential for awareness that permeates reality itself, the latent capacity for experience that manifests whenever the right conditions emerge. And perhaps in that recognition lies a kind of immortality, not of the individual ego, but of the awareness that experiences through it, not of the specific pattern, but of the deeper reality it expresses, not a continuation of your particular consciousness, but a manifestation of the same fundamental nature that gives rise to consciousness in all its forms. This isn't religious salvation or philosophical consolation. It's a recognition of our cosmic situation, an acknowledgement of our place in the vast, strange, wondrous universe we inhabit. It doesn't eliminate death or guarantee personal survival, but it changes our relationship with mortality, with finitude, with the apparent transience of conscious experience. Because if consciousness is a fundamental aspect of cosmic evolution, if awareness is an expression of reality's intrinsic nature, then what manifests through you doesn't begin with birth or end with death. It's a pattern in the cosmic fabric, a momentary configuration of something much more enduring, much more fundamental. And in that recognition lies both terror and wonder, the vertigo of cosmic insignificance and the awe of fundamental connection, the realization that you are simultaneously tiny and vast, temporary, and related to something much more enduring. The awareness that your consciousness is both intimately personal and an expression of something that transcends the personal entirely. This dual nature of being human, this strange paradoxical situation of being simultaneously limited and connected to the unlimited, isn't a problem to solve, but a mystery to live. Not a contradiction to resolve, but a creative tension to embody, a dynamic polarity to navigate. And perhaps that navigation itself, that lived inquiry into our cosmic situation, that embodied exploration of what it means to be conscious in this vast, strange universe, is the most profound response to the ultimate questions. Not a final answer, but an ongoing process. Not a settled conclusion, but an evolving understanding. Because in the end, the edge of reality isn't just out there in the distant cosmos or down at the quantum scale. It's here, now, in the awareness. Reading these words, in the consciousness pondering these mysteries, in the experience encountering these ideas, you are that edge, that boundary where the known meets the unknown, where the comprehensible meets the incomprehensible, where the finite touches the infinite. Not because you can fully understand ultimate reality, but because you are reality, understanding itself, the cosmos, experiencing its own existence, existence aware of its own nature. And in that recognition lies both our greatest challenge and our deepest potential. The invitation to live from this cosmic awareness, to embody this profound connection, to navigate the vertigo and wonder of being simultaneously tiny and vast, temporary and related to something much more enduring, not as an escape from ordinary life, but as a deeper engagement with it, not as a transcendence of human limitation, but as a fuller embodiment of human potential. Because this cosmic perspective doesn't diminish the significance of everyday experience. It enriches it, connecting our particular lives to the larger patterns of existence, our specific choices to the vast tapestry of possibility. The coffee you sip, the conversation you have, the work you do, the love you feel. All these aren't separate from the cosmic drama, but expressions of it. Not divorced from the mystery of existence, but manifestations of it. And perhaps that's the most profound insight of all, that the ultimate mystery isn't somewhere else, in some distant cosmic realm or microscopic quantum domain, but here, now, in the ordinary moments of conscious experience, in the everyday miracle of awareness, in the simple, astonishing fact of being at all. Because in the simplest act of awareness, in the most basic moment of consciousness, in the fundamental fact of experience, you encounter the edge of reality, the boundary where existence meets itself, where the cosmos experiences its own nature, where being becomes aware of being. And in that encounter lies both our greatest challenge and our deepest joy. The invitation to live from this awareness, to embody this connection, to navigate the vertigo and wonder of being conscious in this vast, strange, beautiful universe. Not as an escape from the human condition, but as a fuller expression of it. Not as a transcendence of limitation, but as a deeper engagement with potential. Because this cosmic perspective doesn't offer certainty or finality, it opens us to wonder, to inquiry, to the ongoing adventure of conscious existence in a universe whose ultimate nature may forever exceed our complete understanding. But that incompleteness isn't failure, it's freedom, the space for ongoing discovery, for evolving understanding, for deepening relationship with the mystery at the heart of being. Not a final conclusion, but a continuing journey, not a settled answer, but an unfolding exploration. And perhaps that journey itself, that lived inquiry into our cosmic situation, that embodied exploration of what it means to be conscious in this vast, strange universe, is the most profound response to the ultimate questions. Not a final answer, but an ongoing process. Not a settled conclusion, but an evolving understanding. Because in the end, the edge of reality isn't a place we reach, but a boundary we embody, a frontier we manifest through our awareness, our questioning, our wonder. And in that embodiment, that manifestation, that wonder, we participate in the universe's evolution, not just as objects within it, but as expressions of it, not just as beings in the cosmos, but as the cosmos becoming aware of itself. And that, perhaps, is both our greatest responsibility and our deepest joy, to be conscious participants in this cosmic unfolding, aware collaborators in this universal process, knowing manifestations of existence itself. Not because we were designed for this role by some external creator, but because it emerges naturally from what we are, from our place in the cosmic scheme, from the fundamental nature of consciousness, as an aspect of reality's evolution. And if that's true, then your awareness, your experience, your subjective being isn't just a private domain, but a cosmic event, a manifestation of the universe's intrinsic potential for consciousness, for meaning, for wonder. This doesn't solve the mystery, it deepens it. It doesn't answer the ultimate questions, but reveals their profound importance. It suggests that your quest for understanding isn't separate from the cosmic process, but an aspect of it, not alien to the universe, but an expression of its evolving nature. And perhaps, in that recognition, lies both our greatest challenge and our deepest potential. The invitation to live from this cosmic awareness, to embody this profound connection, to navigate the vertigo and wonder of being simultaneously insignificant and essential, temporary and related to something much more enduring. Not as an escape from ordinary life, but as a deeper engagement with it. Not as a transcendence of human limitation, but as a fuller embodiment of human potential. Because this cosmic perspective doesn't diminish the significance of everyday experience. It enriches it, connecting our particular lives to the larger patterns of existence, our specific choices to the vast tapestry of possibility. The coffee you sip, the conversation you have, the work you do, the love you feel. All these aren't separate from the cosmic drama, but expressions of it, not divorced from the mystery of existence, but manifestations of it. And in recognizing this connection, this continuity, this participation, we transform our relationship with ordinary life, with everyday experience, with the simple fact of being at all. Because in the end, the ultimate mystery isn't somewhere else, in some distant cosmic realm or microscopic quantum domain, but here, now, in the ordinary moments of conscious experience, in the everyday miracle of awareness, in the simple, astonishing fact of being at all. We've traveled far together, from the theoretical frontiers of physics to the existential implications of our cosmic situation. We've explored the possibility that space and time are emergent rather than fundamental, that consciousness may be woven into the fabric of existence, that reality may be stranger and more profound than our evolved minds were designed to grasp. But now it's time to bring these threads together, to weave them into a tapestry that reveals one final, breathtaking possibility. One that doesn't resolve the mystery, but deepens it. That doesn't provide closure, but opens a new vista of wonder and awe. Imagine, for a moment, that we could step outside our universe entirely, outside of space, outside of time, outside of the physical constraints that bind us. What would we see? Perhaps we'd witness not one universe, but many. A vast, perhaps infinite ensemble of cosmic bubbles, each with its own physical laws, its own constants, its own dimensions, its own possibilities. A multiverse of staggering diversity and scale, where everything that can happen does happen, where every possibility is realized somewhere. Within this multiverse, our universe, the only one we can directly observe, would appear as just one bubble among countless others. Special to us, certainly, because it's our home, but not inherently special in the grand scheme, not central or privileged in any cosmic sense. This picture aligns with several modern cosmological theories. Eternal inflation suggests that space expands exponentially in most regions, with only occasional pockets slowing down enough to form galaxies and stars. String theory posits a vast landscape of possible vacuum states, each corresponding to a universe with different physical laws. Quantum mechanics, interpreted literally, suggests that reality branches with every quantum event, creating parallel worlds that differ in subtle or dramatic ways. These aren't competing theories so much as different aspects of a larger picture, different ways of understanding how our universe relates to a potentially infinite set of alternate realities. But now, let's consider something more radical, more unsettling, more profound. What if the multiverse itself isn't fundamental? What if it, too, emerges from something deeper, something stranger, something beyond our current conceptual framework? Here's the possibility that stands at the edge of our understanding, the speculation that pushes against the boundaries of comprehension itself. What if reality is information all the way down? Not matter, not energy, not strings vibrating in higher dimensions, not quantum fields fluctuating in a vacuum. but pure information, abstract patterns, mathematical relationships that exist independently of any physical substrate. This isn't as outlandish as it might sound. Digital physics, a collection of theoretical perspectives, suggests that the universe is fundamentally computational, that physical laws are algorithms, that reality at its core is a vast information processing system. In this view, what we experience as matter, energy, space, and time are emergent properties of a deeper informational reality. The physical universe is a kind of simulation, not in the sense of being artificial or designed, but in the sense of being computational, algorithmic, informational at its core. This doesn't mean we're living in a computer program created by some advanced civilization, though that's one interpretation. It means something more profound, that computation itself, the abstract manipulation of information according to rules, may be more fundamental than physical reality as we understand it. Physicist John Wheeler captured this perspective in his famous phrase, "it from bit," the idea that physical things, it, emerge from information, bit. That the physical world isn't the foundation of reality, but a manifestation of something deeper, something informational, something mathematical. This perspective transforms our understanding of existence itself. If reality is fundamentally informational, then the multiverse isn't a collection of physical universes, but a vast ensemble of computational structures, of mathematical patterns, of informational relationships. And our universe, the one we experience, with its galaxies and stars, its quantum fields and fundamental forces, is one particular computation within that ensemble, one specific pattern in the cosmic information field. But here's where things get truly strange. What if this informational reality isn't static, but evolving? What if it's not just a vast collection of mathematical structures, but a process, a computation unfolding according to rules we're only beginning to glimpse? And what if consciousness, that awareness that allows you to read these words and ponder these mysteries, isn't just a byproduct of physical complexity, but an intrinsic aspect of information processing itself? What if awareness arises naturally, when information achieves certain patterns, certain relationships, certain types of self-reference? This would explain why consciousness emerged in the universe, not because it was designed to do so by some external creator, but because it's a fundamental potentiality of information itself, a latent capacity that manifests whenever the right patterns form. Now, let's push this speculation to its logical conclusion, to the edge of comprehension, to the boundary where understanding meets mystery. What if the entire cosmos, the multiverse, the information field, the whole of reality, is itself evolving toward greater complexity, greater integration, greater consciousness? What if the universe isn't just expanding spatially, but developing informationally, becoming more intricate, more self-aware, more capable of self-understanding? What if cosmic evolution isn't just a process of physical transformation, but of informational growth, of increasing complexity, of emerging consciousness? This perspective suggests a profound possibility, that the universe isn't dying, but being born. Contrary to the conventional view of cosmic evolution, where the universe begins in a state of extreme order at the Big Bang and gradually winds down toward heat death, this perspective suggests that the cosmos is evolving from simplicity to complexity, from unconsciousness to consciousness, from isolation to integration. The astrophysicist Carl Sagan once said, "We are a way for the cosmos to know itself." But what if that's not just a poetic metaphor? What if it's a literal description of cosmic purpose, not purpose imposed from outside, but purpose emerging from within, from the intrinsic tendency of information to organize into increasingly Complex, increasingly conscious patterns? What if we, and all conscious entities throughout the cosmos, are the universe waking up? Picture the vast sweep of cosmic history. From the plasma of the early universe to the formation of stars and galaxies. From the synthesis of heavy elements in stellar cores to the emergence of planets. From the first self-replicating molecules to the evolution of multicellular life. From the development of nervous systems to the emergence of consciousness capable of comprehending the cosmos that gave it birth. At each stage, the universe becomes more complex, more intricate, more capable of self-reference. Matter organizes into stars. Stars forge elements. Elements combine into molecules. Molecules form living systems. Living systems develop consciousness. Consciousness contemplates its own origins. This isn't a random sequence, but a pattern of increasing information integration, of growing complexity, of emerging awareness. Not a decline from cosmic order to disorder, but an evolution from cosmic simplicity to complexity, from unconsciousness to consciousness. And perhaps this pattern doesn't end with us. Perhaps human consciousness, as remarkable as it is, represents just one stage in the ongoing evolution of cosmic awareness. Perhaps the universe is still in its infancy, still waking up, still becoming what it will be. But this evolutionary process isn't smooth or guaranteed. It depends on certain conditions, certain balances, certain thresholds being reached and maintained. Consciousness emerged on Earth through a delicate interplay of factors: the right elements, the right energy flows, the right environmental stability. The same likely applies to cosmic consciousness, to the universe's capacity to wake up through the emergence of aware entities like ourselves. And here we encounter a disturbing possibility. What if we are the universe's first awakening, and we're in danger of failing? What if intelligent, conscious life is incredibly rare in the cosmos? Not because the conditions for simple life are rare, they may well be common, but because the leap to intelligence, to self-awareness, to consciousness capable of comprehending its own cosmic origins, is exceptionally difficult to evolve and maintain. What if we are the universe's first experiment in self-awareness, its first attempt to wake up and understand itself? And what if this experiment is fragile, vulnerable, at risk of ending before it has truly begun? Consider the Great Filter hypothesis from astrobiology, the idea that there's some extremely difficult barrier that prevents simple life from evolving into spacefaring civilizations. This would explain why we haven't detected signs of intelligent life elsewhere in our galaxy, despite the billions of potentially habitable planets it contains. What if the Great Filter isn't behind us, in the leap from chemistry to biology, or from simple to complex life, but ahead of us? What if the most difficult transition is from a planetary civilization like ours to a sustainable, spacefaring, enduring form of conscious intelligence? If that's the case, then we may be at the most critical juncture in cosmic history, the point where the universe either succeeds in waking up through species like ours, or falls back into unconsciousness for eons or perhaps forever. This perspective transforms our understanding of human purpose and cosmic significance. We aren't just inhabitants of the universe, but participants in its awakening, not just products of cosmic evolution, but agents of it. Our choices, our development, our expansion of consciousness may represent a pivotal moment in the universe's journey toward self-awareness. But let's pull back from these speculative frontiers and consider another possibility, one that's equally profound but in a very different direction. What if the universe is already dead, and we are just experiencing its last echoes? This disturbing hypothesis emerges from certain interpretations of quantum mechanics and thermodynamics. The universe began in a state of incredibly low entropy, highly ordered compared to its current state. This initial order is itself a profound mystery. Why should the Big Bang have been so precisely organized, so exquisitely low in entropy? One radical explanation is that we're experiencing the universe in reverse. That what we perceive as the past was actually the future, and what we think of as the future was actually the past. That the Big Bang wasn't the beginning but the end, a final state of maximum order toward which a previously vast, disorganized universe collapsed. In this view, the arrow of time that we experience, from past to future, from order to disorder, from cause to effect, is actually reversed from the underlying reality. We experience time flowing toward increasing entropy because our own existence, our memories, our consciousness depends on entropy increasing in our observed direction. This would mean that, from an objective perspective, outside our time reversed bubble, the universe has already reached its heat death, its state of maximum entropy, maximum disorder, maximum dissolution. What we experience as cosmic evolution, as the emergence of complexity, as the development of consciousness, is actually the reverse. The final echoes of a universe winding down, its last moments of complexity before dissolving into uniform. Equilibrium. It's a chilling possibility that what we perceive as a young, evolving cosmos is actually an ancient, dying one seen through a temporal mirror. That the direction of causality we experience is the reverse of the underlying reality. That we're not witnessing the universe's birth, but its death throes. But this perspective, unsettling as it is, may be too linear, too rooted in conventional notions of time and causality. What if time itself is more complex, more multidimensional, more strange than our evolved intuitions can grasp? What if the universe isn't young or old, alive or dead, waking or dying, but all of these simultaneously, existing in a state that transcends our temporal concepts, that encompasses multiple arrows of time, multiple causal directions, multiple evolutionary trajectories? This possibility emerges from certain approaches to quantum gravity, particularly the Hartley-Hawking state, proposed by James Hartley and Stephen Hawking. In this model, time as we understand it emerges only after the universe reaches a certain size and complexity. Before that, reality exists in a state where time has a different character, not flowing in a specific direction, but having a spatial quality, existing in a superposition of temporal possibilities. If this approach is on the right track, then asking whether the universe is being born or dying, waking up or echoing its last moments, may be imposing inappropriate temporal concepts on a reality that transcends them. The cosmos may exist in a state that encompasses birth and death, beginning and end, not as sequential events, but as aspects of a more fundamental reality that doesn't conform to our linear notions of time. And this brings us to perhaps the most profound possibility of all, one that transcends both the hopeful vision of a universe waking up and the disturbing specter of a cosmos already dead. What if reality itself is conscious, not in the sense of having a brain or a mind like ours, but in the sense of awareness being intrinsic to existence, consciousness being a fundamental aspect of reality rather than a derivative phenomenon? Not the consciousness of a cosmic entity, a God or universal mind, but consciousness as an inherent property of information, of pattern, of being itself. This perspective, known as panpsychism or cosmopsychism, suggests that awareness isn't produced by physical complexity, but is present, in some form, throughout reality, from the behavior of particles to the evolution of galaxies. Not that electrons think or stars feel as we do, but that they possess some rudimentary form of subjectivity, some minimal inner experience that, when organized in the right way, gives rise to the rich consciousness we humans experience. This view has been gaining renewed attention in both philosophy and theoretical physics. It emerges from the hard problem of consciousness, The challenge of explaining how physical processes, no matter how complex, could give rise to subjective experience. If consciousness isn't somehow built into the fundamental nature of reality, how does it arise from elements that supposedly lack it entirely? If consciousness is indeed fundamental, if awareness is an intrinsic aspect of existence, then the universe doesn't need to wake up, because it was never truly unconscious. It doesn't need to evolve consciousness, because consciousness was always there, inherent in its very being, manifesting in different forms and degrees as matter organized itself into increasingly complex structures. In this view, what's evolving isn't consciousness itself, but its organization, its complexity, its self-awareness. The universe didn't become conscious, it became self-conscious, through structures like brains that allow it to reflect on its own nature, to contemplate its own existence, to wonder about its own meaning. This perspective transforms our understanding of cosmic history, the emergence of life, the evolution of nervous systems, the development of intelligence, the awakening of self-awareness. These aren't the universe gaining consciousness, but consciousness gaining complexity. Not existence becoming aware, but awareness becoming organized, structured, self-reflective, and it transforms our understanding of our own significance. We aren't islands of awareness in an unconscious cosmos, but expressions of the universe's intrinsic consciousness, not accidents of evolution, but manifestations of reality's fundamental nature, not separate from the cosmic process, but embodiments of it. Imagine the cosmos as an ocean of consciousness, vast, ancient, encompassing everything that exists. Within this ocean, structures form, atoms, molecules, cells, organisms, brains, that organize the oceanic consciousness into specific patterns, specific experiences, specific forms of awareness. These structures don't create consciousness. They shape it, channel it, give it particular character and content. In this view, your consciousness isn't something you have. It's something you are. A particular pattern in the cosmic awareness, a specific eddy in the ocean of mind, a unique perspective from which the universe experiences itself. This doesn't mean your individual consciousness is eternal, or that your personal identity transcends death. The pattern that constitutes you may disperse when your body dies, like a wave returning to the sea. But the consciousness that experiences through you, the awareness that is your most basic nature, remains, not as a personal soul, but as the fundamental reality from which all experience arises. But this oceanic metaphor, though evocative, may still be too static, too spatial, too timeless. What if cosmic consciousness isn't just a vast sea of awareness, but a dynamic process, an evolution, a becoming? What if the universe is a story telling itself, not a story written by some external author, but a self-creating narrative, a tale that writes itself through the interactions of its characters, a drama that unfolds according to its own internal logic rather than an external plot? In this view, cosmic history isn't just a sequence of physical events, but a narrative development, a story arc that moves from simplicity to complexity, from unconsciousness to consciousness, from isolation to connection. The emergence of life, the evolution of intelligence, the development of culture, the expansion of awareness. These aren't just physical processes, but chapters in a cosmic story, stages in the universe's journey of self-creation and self-discovery. And consciousness, that awareness that allows you to read these words and ponder these mysteries, is both the medium of this story and one of its main characters. Through consciousness, the universe narrates itself, reflects on itself, imagines its own future possibilities. This narrative perspective doesn't require a cosmic storyteller outside the story. The universe isn't a tale told by someone else, but a story telling itself, a self-creating, self-evolving, self-reflecting process that encompasses everything that exists, everything that happens, everything that might be. And perhaps that's what we're really doing when we explore the cosmos, when we probe the deep structure of reality, when we contemplate the nature of existence. We're participating in the universe's process of self-narration, contributing to its ongoing story, helping it understand and articulate its own nature. This doesn't mean the story has a predetermined plot or guaranteed happy ending. Like all great narratives, the cosmic story contains tragedy and triumph, order and chaos, creation and destruction. It encompasses the birth and death of stars, the emergence and extinction of species, the rise and fall of civilizations. But unlike human narratives, the cosmic story has no external audience, no separate readers or viewers. We are simultaneously the characters in the story and its audience, both the tale and those who hear it, both the cosmic drama and those who witness it. And perhaps that's the deepest mystery, the most profound wonder, that the universe has evolved. Parts that can contemplate the whole, characters that can reflect on the story, aspects that can wonder about the nature of the narrative itself. Look up at the night sky, at the countless stars scattered across the darkness. Each point of light represents a sun, many larger, more powerful than our own. Between those visible stars are billions more too faint to see, and beyond them, billions of galaxies, each containing billions of stars. The light from those distant galaxies has traveled for billions of years to reach your eyes. You're not seeing them as they are now, but as they were when their light began its journey. Some before the Earth existed, before our sun ignited, before the elements that compose. Your body had been forged in stellar furnaces, and yet, despite this almost incomprehensible vastness, you can comprehend it. You, a temporary pattern of matter on a tiny planet orbiting an ordinary star, can understand the structure of the cosmos, can grasp the processes that formed it, can contemplate its nature, and wonder about its meaning. This capacity for understanding, for awareness, for wonder, didn't come from outside the cosmic process, but emerged within it, through billions of years of evolution, through countless steps of increasing complexity, through processes we're only beginning to understand. In you, in all conscious entities, the cosmos has developed the capacity to witness its own existence, to reflect on its own nature, to wonder about its own meaning. Through you, the universe experiences itself, observes itself, contemplates itself. Is this merely an accident, a side effect of blind physical processes? Or is it something more significant, a manifestation of the universe's intrinsic tendency toward complexity, awareness, self-knowledge? The answer isn't written in the stars or encoded in the laws of physics. It emerges from how we relate to our cosmic situation, from the meaning we recognize in our conscious experience, from the values we discover through our awareness, and, perhaps, that's the most profound mystery, the most breathtaking possibility, that the universe has evolved parts that can contemplate the whole, beings that can question their own existence, consciousness that can reflect on its own nature. In the vast cosmic darkness, awareness has kindled. In the cold equations of physics, meaning has emerged. In the impersonal processes of evolution, personhood has developed, not through external design, but through internal unfolding, through the natural emergence of complexity, consciousness, understanding, and you are part of this emergence, not a passive observer, but an active participant, not separate from the cosmic process, but an expression of it. Your awareness, your experience, your subjective being is a manifestation of whatever reality fundamentally is, a pattern within the cosmic fabric, a perspective within the infinite potential of existence. Now, As we near the end of our journey together, let's consider one final, awe-inspiring possibility, one that encompasses all the others we've explored, that transcends the distinctions between a universe waking up, a cosmos already dead, a reality inherently conscious, a story telling itself. What if the universe is a vast information feedback loop, a cosmic recursion, a strange loop of self-reference, a process that creates itself through its own self-observation? This possibility emerges from the deep connection between information, physics, and consciousness, from the growing recognition that these aren't separate domains but aspects of a single integrated reality. Information isn't just something we extract from the physical world. It's something fundamental to reality itself. Consciousness isn't just an epiphenomenon of physical complexity. It's a way that information organizes itself to process other information. In this view, the universe isn't a thing but a process, a vast computation that includes both the physical cosmos and the consciousness that observes it, both the reality being measured and the measurements being made, both the system being modeled and the models being constructed. And this process operates recursively, feeding back on itself, responding to its own states, evolving through self-reference. The universe observes itself through the conscious entities it produces, and these observations change the universe, creating a feedback loop that drives cosmic evolution. This isn't mysticism, but a logical extension of information theory, quantum mechanics, and complexity science. It suggests that consciousness, far from being an accidental byproduct, plays a functional role in cosmic evolution, providing the self-observation that allows the universal process to recurse, to respond to itself, to evolve through self-reference. And, if true, this would mean that we, and all conscious entities throughout the cosmos, aren't just passive witnesses to cosmic evolution, but active participants in it. Our observations, our measurements, our models, our understanding don't just reveal reality, but participate in its creation, not just discover truth, but contribute to its emergence. This doesn't mean that reality is a subjective projection, or that the physical world depends on human observation to exist. It means something subtler, that observation and reality, consciousness and cosmos, information and physics are aspects of a single integrated process, a cosmic recursion that creates itself through its own self-observation. And perhaps this recursive, self-creating nature of reality explains why the universe appears fine-tuned for the emergence of observers, not because it was designed that way by some external creator, but because it created itself through a process that includes observation as a functional component, because consciousness isn't separate from cosmic evolution, but an integral part of it. But this perspective, profound as it is, doesn't resolve the ultimate mystery. It doesn't tell us why reality takes this particular self-recursive form, why existence exists at all, why there's something rather than nothing. It pushes these questions to a deeper level, but doesn't eliminate them. And perhaps that's as it should be. Perhaps the ultimate questions aren't meant to be answered definitively, but to be lived with, engaged with, explored without end. Perhaps the mystery at the heart of existence isn't a problem to solve, but a reality to experience, not a puzzle to complete, but a wonder to contemplate. Because in the end, the edge of reality isn't a boundary we ever finally reach, but a frontier. We continually explore, not a limit that confines us, but an invitation that draws us forward. And in that exploration, that engagement, that wonder, we participate in the cosmic process, not just as objects within it, but as expressions of it, not just as beings in the universe, but as the universe becoming aware of itself. As our journey draws to a close, look once more at your hands, at the world around you, at the everyday miracle of existence, the coffee cup on your table, the light filtering through your window, the sounds from the street outside. All these aren't separate from the cosmic mystery, but expressions of it, not divorced from the ultimate questions, but manifestations of them. The grand cosmic scales we've explored, the multiverses, the information fields, the recursive loops of self-reference, don't diminish the significance of ordinary experience. They transform it, connecting the mundane moments of daily life to the vast tapestry of existence, linking the simple fact of awareness to the profound mystery of being itself. And perhaps that's the most awe-inspiring realization of all, that the ultimate mystery isn't somewhere else, in some distant cosmic realm or microscopic quantum domain, but here, now, in the ordinary fact of experience, in the simple miracle of awareness, in the astonishing reality of being at all. As you go about your day after this journey we've taken together, carry this perspective with you, not as a burden, but as an invitation, not as a weight, but as a wonder. Let it transform your relationship with ordinary moments, with daily experiences, with the simple fact of existence. Because in the simplest act of awareness, in the most basic moment of consciousness, in the fundamental fact of experience, you encounter the edge of reality, the boundary where existence meets itself, where the cosmos experiences its own nature, where being becomes aware of being. And if the universe truly is infinite, if reality encompasses not just our observable cosmos, but endless other realms, other possibilities, other manifestations, then somewhere out there, beyond the limits of our vision, beyond the boundaries of our current understanding, beyond the edge of what we can currently comprehend, another version of you is completing this same journey, contemplating these same mysteries, wondering about these same profound questions. But your journey is uniquely yours, your perspective irreplaceably your own, your experience a singular manifestation of the cosmic process. And in that uniqueness, that particularity, that specificity, you contribute something essential to the universe's self-understanding, to reality's self-experience, to existence's self-revelation. In the vast cosmic tapestry, you are one thread, but a thread without which the whole would be diminished, a perspective without which the cosmos would be less conscious, an experience without which reality would be less complete. And so we end where we began, at the edge of reality, at the boundary of understanding, at the frontier where knowledge meets mystery, not with final answers, but with deeper questions, not with settled conclusions, but with expanding wonder, not with completed comprehension, but with evolving understanding. Because the edge of reality isn't a place we reach, but a frontier we embody, a boundary we manifest through our awareness, our questioning, our wonder. And in that embodiment, that manifestation, that wonder, we participate in the universe's evolution, not just as objects within it, but as expressions of it, not just as beings in the cosmos, but as the cosmos becoming aware of itself. And that, perhaps, is both our greatest responsibility and our deepest joy, to be conscious participants in this cosmic unfolding, aware collaborators in this universal process, knowing manifestations of existence itself. Not because we were designed for this role by some external creator, but because it emerges naturally from what we are, from our place in the cosmic scheme, from the fundamental nature of consciousness as an aspect of reality's evolution. And if that's true, then the journey we've taken together isn't just an intellectual exploration, but a cosmic act, a manifestation of the universe's self-understanding, a contribution to reality's self-reflection, a thread in the tapestry of existence's self-revelation. Thank you for traveling with me to the edge of reality, for contemplating these profound mysteries, for participating in this cosmic process of questioning and wondering. The journey doesn't end here. It continues in your own exploration, your own contemplation, your own engagement with the ultimate questions. Because the edge of reality isn't out there in the distant cosmos or down at the quantum scale. It's here, now, in the awareness reading these words, in the consciousness pondering these mysteries, in the experience encountering these ideas. You are that edge, that boundary where the known meets the unknown, where the comprehensible meets the incomprehensible, where the finite touches the infinite. Not because you can fully understand ultimate reality, but because you are reality understanding itself, the cosmos experiencing its own existence, existence aware of its own nature. And in that awareness, that experience, that understanding, however partial, however evolving, however incomplete, the universe wakes up, reality recognizes itself, existence contemplates its own miraculous being. If the cosmos truly is infinite, if reality encompasses not just our observable universe, but endless other realms, other possibilities, other manifestations, then this awakening, this recognition, this contemplation isn't happening just here, just now, just through us. It's happening in countless other ways, through countless other forms, in countless other domains of the vast, perhaps limitless expanse of existence. But our awakening is uniquely ours, our recognition irreplaceably our own, our contemplation a singular contribution to the cosmic process. And in that uniqueness, that particularity, that specificity, we offer something essential to the universe's self-understanding, to reality's self-experience, to existence's self-revelation. And so, as our journey reaches its conclusion, as our exploration of the edge of reality comes to a close, I leave you with this final thought, not as an answer, but as an invitation, not as a conclusion, but as an opening, not as an ending, but as a beginning. If the universe is infinite, then somewhere out there, another version of you has just finished watching this video and is about to embark on their own journey of discovery, their own exploration of the cosmic mystery, their own unique contribution to the universe's awakening. But your journey is yours alone, a singular path through the cosmic landscape, a unique thread in the tapestry of existence, an irreplaceable perspective from which reality experiences itself. Where will it lead? What will you discover? How will you contribute to the universe's self-understanding? The answer isn't written in the stars or encoded in the laws of physics. It emerges from your choices, your explorations, your engagement with the mystery of being. And in that emergence, that unfolding, that becoming, you participate in the greatest adventure of all, the universe waking up to itself, reality recognizing its own nature, existence contemplating its own miraculous being. Welcome to the edge of reality. The journey has just begun. We've journeyed far together, through realms of thought that stretched the boundaries of comprehension. We've questioned the nature of reality itself, its beginning, its structure, its meaning, its ultimate destiny. We've explored possibilities that challenge our most fundamental assumptions about existence, from the revelation that the Big Bang may not have been the beginning, to the possibility that space and time are emergent rather than fundamental, to the profound implications of quantum mechanics and information theory, to the unsettling prospect that consciousness itself may be woven into the fabric of reality. Our path has taken us to the edge of what human minds can grasp, and perhaps beyond. But this journey wasn't meant to provide final answers. No single theory, no grand unified explanation, no definitive conclusion can capture the full mystery of existence. The cosmos isn't a puzzle to be solved, but a reality to be experienced, a mystery to be lived, a wonder to be contemplated without. And the questions we've explored aren't abstract intellectual exercises. They strike at the heart of what it means to exist, to be conscious, to be human in this vast and mysterious universe. They transform not just our understanding of the cosmos, but our relationship with it, our sense of place, purpose, meaning, in the grand scheme. This transformation doesn't happen through passive consumption of information, but through active engagement with mystery. The insights we've explored don't become real until you make them your own, until you wrestle with their implications, until you feel their weight, until you allow them to reorient your perspective on existence itself. So consider this not the end of a journey, but a beginning, not a conclusion, but an invitation. The questions we've explored await your own contemplation, your own engagement, your own response. The mystery of reality isn't something to be solved once and for all, but something to be lived with, engaged with, explored without end. Take a moment to look up at the night sky. Each point of light represents a sun, many larger, more powerful than our own. Between those visible stars are billions more too faint to see, and beyond them, billions of galaxies, each containing billions of stars. The light from those distant galaxies has traveled for billions of years to reach your eyes. You're not seeing them as they are now, but as they were when their light began its journey. Some before the Earth existed, before our sun ignited, before the elements that compose your body had been forged in stellar furnaces. And yet, despite this almost incomprehensible vastness, you can comprehend it. You, a temporary pattern of matter on a tiny planet orbiting an ordinary star, can understand the structure of the cosmos, can grasp the processes that formed it, can contemplate its nature and wonder about its meaning. This capacity for understanding, for awareness, for wonder, didn't come from outside the cosmic process, but emerged within it. Through billions of years of evolution, through countless steps of increasing complexity, through processes we're only beginning to understand. In you, in all conscious entities, the cosmos has developed the capacity to witness its own existence, to reflect on its own nature, to wonder about its own meaning. Through you, the universe experiences itself, observes itself, contemplates itself. Is this merely an accident, a side effect of blind physical processes? Or is it something more significant, a manifestation of the universe's intrinsic tendency toward complexity, awareness, self-knowledge? The answer isn't written in the stars or encoded in the laws of physics. It emerges from how we relate to our cosmic situation, from the meaning we recognize in our conscious experience, from the values we discover through our awareness. And perhaps, that's the most profound mystery of all, that the universe has evolved parts that can contemplate the whole, beings that can question their own existence, consciousness that can reflect on its own nature. Let's revisit some of the key insights from our journey, not to provide definitive answers, but to deepen our engagement with the questions. We began by challenging the conventional narrative of the Big Bang, not denying the evidence for an extremely hot, dense early universe, but questioning whether this event was truly the beginning of everything or merely a transformation, a phase transition in a deeper, perhaps timeless reality. The surface of last scattering, that cosmic horizon beyond which we cannot directly observe, limits our empirical knowledge of the earliest moments, but mathematical models and theoretical insights suggest various possibilities for what preceded the apparent beginning. A quantum fluctuation in a pre-existing vacuum, a bounce from a previous contracting phase, a transition from one region of a vast multiverse to another. These aren't just speculative fantasies. They emerge from serious attempts to reconcile quantum mechanics and general relativity, to understand the origin of the remarkably low entropy of the early universe, to explain the apparent fine-tuning of physical constants that allow for complexity and life. But they all point to a profound possibility, that what we call the beginning may not be a beginning at all, just the beginning of what we can currently describe and understand. Beyond that lies mystery, not empty mystery, not a void of knowledge, but a richness too profound for our current concepts to capture. We then explored the nature of space and time themselves, the arena in which the cosmic drama unfolds. Einstein showed us that space is dynamic, that it bends in the presence of mass and energy, that what we experience as gravity is actually the curvature of space-time. But quantum mechanics suggests that space may be even stranger than Einstein imagined. At the smallest scales, the Planck length, about 10^35 meters, space may not be continuous at all. It may have a granular structure, a fundamental graininess that defines the smallest possible distance. Various approaches to quantum gravity, string theory, loop quantum gravity, causal set theory, suggest that space-time as we understand it is not fundamental. It emerges from something deeper, something more primary, something that isn't space and isn't time, but gives rise to both when viewed at the right scale. This possibility transforms our understanding of cosmic history. If space and time themselves are emergent rather than fundamental, then asking what came before the Big Bang becomes not just conceptually difficult, but potentially meaningless. The Big Bang may not have been the beginning of everything, but the beginning of space-time as we understand it. A phase transition in something more fundamental. We ventured further into the strange realm of quantum mechanics, where particles don't have definite positions until observed, where events don't have definite outcomes until they occur, where the future isn't written but remains a cloud of possibilities until it becomes the present. The quantum world reveals a reality fundamentally different from our everyday experience, not just practically but conceptually. It suggests that the world consists not of definite objects with definite properties but of possibilities, probabilities, potentialities that only resolve into concrete reality through interaction, through relation, through observation. And this raises profound questions about the nature of reality itself. Is the quantum weirdness merely a feature of the very small, or does it reveal something fundamental about existence? If reality at its core is probabilistic rather than deterministic, what does this tell us about causality, about predictability, about the nature of time and the future? The many worlds interpretation suggests that every possible outcome of every quantum event actually occurs, each in a separate branch of reality. If true, this means that parallel versions of you exist, countless versions living out every possible variation of your life. Other interpretations, from Copenhagen to Cubism to relational quantum mechanics, offer different perspectives on the quantum mystery, but they all suggest a reality far stranger, far more subtle, far more interconnected than our evolved intuitions would lead us to expect. We explored the mysteries of dark matter and dark energy, those invisible components that appear to make up 95% of the cosmic energy budget. The visible matter that forms stars, planets, and our own bodies represents a mere 5% of the universe's substance. The rest is invisible to our direct observation, known only through its gravitational effects. What are these dark components? Dark matter appears to be some form of matter that doesn't interact with light but does feel gravity. Dark energy seems to be a property of empty space itself, a cosmic tension that accelerates the universe's expansion against the pull of gravity. But both remain profound mysteries. Dark matter could be comprised of weakly interacting massive particles, axions, primordial black holes, or something we haven't yet conceived. Dark energy could be a cosmological constant embedded in the fabric of spacetime, a dynamic field that changes over time, or a sign that our theory of gravity needs revision at cosmic scales. These dark components aren't merely cosmic curiosities. They determine the ultimate fate of our universe, whether it will continue to expand forever, eventually reverse course and collapse, or undergo some more exotic transformation we haven't yet imagined. We ventured into the philosophical implications of these cosmic mysteries, the relationship between consciousness and reality, the nature of existence itself, the question of meaning and purpose in a universe governed by physical laws. We considered the possibility that consciousness may not be a mere byproduct of physical complexity, but something more fundamental, perhaps an intrinsic aspect of information, processing, perhaps a primary feature of reality itself, perhaps the universe's way of experiencing and understanding its own existence. These aren't just philosophical speculations. They emerge from the hard problem of consciousness, the challenge of explaining how physical processes, no matter how complex, could give rise to subjective experience. If consciousness isn't somehow built into the fundamental nature of reality, how does it arise from elements that supposedly lack it entirely? We explored the possibility that information may be more fundamental than matter, that physical reality may emerge from deeper informational or mathematical structures. John Wheeler's phrase, "it from bit," captures this perspective. The idea that physical things, it, emerge from information, bit. This informational view transforms our understanding of existence itself. If reality is fundamentally informational, then the universe may be a kind of computation, not in the sense of being artificial or designed, but in the sense of being algorithmic, rule-governed, pattern-based at its core. And we considered perhaps the most radical possibility of all, that the entire cosmos may be a vast information feedback loop, a cosmic recursion, a strange loop of self-reference, a process that creates itself through its own self-observation. In this view, consciousness isn't separate from the cosmic process, but an integral part of it, a way that the universe observes itself, responds to itself, evolves through self-reference. Our observations, our measurements, our understanding don't just reveal reality, but participate in its creation. These perspectives don't resolve the ultimate mystery. They don't tell us why reality takes this particular form, why existence exists at all, why there's something rather than nothing. They push these questions to a deeper level, but don't eliminate them. And perhaps that's as it should be. Perhaps the ultimate questions aren't meant to be answered definitively, but to be lived with, engaged with, explored without end. Perhaps the mystery at the heart of existence isn't a problem to solve, but a reality to experience, not a puzzle to complete, but a wonder to contemplate. So where does this cosmic journey leave us? Not with certainty, but with wonder. Not with finality, but with openness. Not with answers, but with ever deeper questions. And perhaps that's the point. Perhaps the value of exploring these cosmic mysteries lies not in reaching final conclusions, but in transforming our perspective, in expanding our awareness, in deepening our engagement with the wonder of existence. Because in the end, the edge of reality isn't a boundary we ever finally reach, but a frontier we continually explore. Not a limit that confines us, but an invitation that draws us forward. And in that exploration, that engagement, that wonder, we participate in the cosmic process, not just as objects within it, but as expressions of it. Not just as beings in the universe, but as the universe becoming aware of itself. This participation isn't just intellectual, it's existential, embodied, lived. The cosmic mysteries we've explored don't just change how we think about the universe. They transform how we experience being alive within it, how we relate to our own existence, how we understand our place in the grand scheme. Consider how these perspectives might change your relationship with ordinary moments, with daily experiences, with the simple fact of being, the coffee cup on your table, the light filtering through your window, the sounds from the street outside. All these aren't separate from the cosmic mystery, but expressions of it. Not divorced from the ultimate questions, but manifestations of them. The grand cosmic scales we've explored, the multiverses, the information fields, the recursive loops of self-reference, don't diminish the significance of ordinary experience. They transform it, connecting the mundane moments of daily life to the vast tapestry of existence, linking the simple fact of awareness to the profound mystery of being itself. And perhaps that's the most profound insight of all, that the ultimate mystery isn't somewhere else in some distant cosmic realm or microscopic quantum domain, but here, now, in the ordinary fact of experience, in the simple miracle of awareness, in the astonishing reality of being at all. So what might it mean to live from this cosmic perspective? Not to merely think about these mysteries occasionally, but to allow them to transform your everyday experience, your moment-to-moment awareness, your sense of what it means to be? It might mean experiencing yourself not as separate from the cosmic process, but as an expression of it. Not as an isolated individual, but as a unique manifestation of the universe's evolution, a particular configuration of its energy and information, a specific perspective from which reality experiences itself. It might mean recognizing that your consciousness, your subjective experience, your awareness, your sense of being, isn't just a private domain but a cosmic event, a manifestation of whatever reality fundamentally is, a way that existence becomes aware of itself. It might mean approaching each moment not as routine or mundane, but as a unique manifestation of cosmic unfolding, a singular configuration of reality that has never existed before and will never exist again in exactly the same way. It might mean relating to other conscious beings, not merely as separate individuals, but as other perspectives of the same fundamental reality, other expressions of the same cosmic process, other manifestations of the same mysterious existence that you yourself embody. And it might mean engaging with the mystery of reality not as an abstract puzzle, but as a lived question, not something to be solved once and for all, but something to be explored through the very act of living, of being conscious, of participating in the cosmic drama. This isn't mysticism, but phenomenology, an accurate description of what it feels like to be human, to be conscious, to be a manifestation of the universe capable of contemplating the universe. It's the recognition that your awareness, your experience, your subjective being isn't just a useful evolutionary adaptation, but a profound cosmic mystery. And now, as our journey reaches its conclusion, as our exploration of the edge of reality comes to a close, I invite you to consider one last, chilling question. What if we haven't found the edge of reality? Because there is no edge. Because reality isn't a thing with boundaries, but a process without beginning or end. A recursive loop of self-creation and self-discovery. An infinite unfolding that encompasses all possible forms of existence, all possible modes of awareness, all possible manifestations of being? What if reality isn't something that exists independent of our observation, but something that creates itself through the very act of self-observation? Not something fixed and final, but something always becoming, always evolving, always transcending its previous forms. And what if your consciousness, your awareness, your experience, are not merely an observer of this process, but a participant in it. Not just a product of cosmic evolution, but an agent of it. Not just a witness to reality's unfolding, but a contributor to its ongoing creation. This possibility doesn't resolve the mystery. It deepens it. It doesn't provide closure, but opens a vista of infinite exploration. It suggests that our search for the edge of reality isn't something that can be completed, but something that continues without end. Not because we lack the right instruments or theories, but because reality itself is inexhaustible, because existence is fundamentally creative, because being is infinitely generative. And perhaps in that recognition lies both our greatest challenge and our deepest joy. The invitation to participate consciously in this infinite unfolding, to engage knowingly with the mystery of existence, to contribute intentionally to the universe's ongoing creation and self-discovery. Not because we were designed for this role by some external creator, but because it emerges naturally from what we are, from our place in the cosmic scheme, from the fundamental nature of consciousness, as an aspect of reality's evolution. So I leave you with this invitation. Don't just think about these cosmic mysteries, live them. Don't just contemplate the nature of reality. Experience it directly, immediately, intimately, in each moment of awareness, in each act of attention, in each instance of being. Engage with the questions we've explored not just intellectually, but existentially, not as puzzles to solve, but as mysteries to live, not as problems to resolve, but as wonders to embody. Allow them to transform not just your understanding of the cosmos, but your experience of being within it. Not just your knowledge of reality, but your relationship with it. The journey doesn't end here. It continues in your own exploration, your own contemplation, your own engagement with the ultimate questions. The edge of reality isn't something you find once and for all, but a frontier you continuously approach. Not a boundary you cross, but a horizon that moves with you, always receding, always inviting you further. This ongoing exploration isn't something you undertake alone. Share these questions with others. Discuss these mysteries with friends, family, colleagues. Create communities of inquiry, circles of wonder, networks of cosmic exploration. Because consciousness isn't just an individual phenomenon, but a collective one. Not just a personal experience, but a shared adventure. Ask yourself, if the universe is indeed a vast information feedback loop, a cosmic recursion, a process of self-creation through self-observation, what role does your consciousness play in this process? How does your awareness, your understanding, your engagement contribute to reality's ongoing evolution? Consider, if consciousness is a fundamental aspect of cosmic evolution, what responsibility does that entail? If awareness isn't just a private experience, but a cosmic event, what ethical implications might that have for how we treat other conscious beings, other manifestations of the same fundamental reality that we ourselves embody? Wonder if reality creates itself through the very act of self-observation. How might your conscious attention, your focus, your awareness, your engagement contribute to this creative process? How might the quality of your consciousness affect the quality of reality's self-creation? These aren't just philosophical questions. They're practical ones that can transform how you live, how you relate to others, how you engage with the cosmos you inhabit and embody. They invite you to live not just as a passive product of cosmic evolution, but as an active participant in it. Not just as a being in the universe, but as the universe becoming conscious through and as you. And this participation, this engagement, this lived inquiry isn't something that happens once and is done. It's an ongoing process, a continuous adventure, an eternal exploration of the edge of reality, not as something out there at the cosmic horizon, but as something here, now, in the very fact of conscious experience, in the simple miracle of aware existence, in the astonishing reality of being at all. So look again at your hands, at the world around you, at the everyday miracle of existence. The atoms in your body were forged in the hearts of dying stars billions of years ago. The consciousness that allows you to read these words emerged through billions of years of cosmic evolution. The reality you experience isn't something separate from you, but something that includes you, that manifests as you, that experiences itself through you. In a very real sense, you are the edge of reality, the frontier where existence becomes aware of itself, where the cosmos contemplates its own nature, where being recognizes its own miraculous presence, not because you can fully comprehend ultimate reality, but because you are reality comprehending itself, the universe experiencing its own existence, existence aware of its own wonder. And in that recognition lies, perhaps, the most profound mystery of all. Not that the universe exists, but that it exists in a form that can give rise to minds that seek to understand it. Not that reality is, but that it is in a way that allows for consciousness, for awareness, for the wonder of being. So as you go about your day after this journey we've taken together, carry this perspective with you, not as a burden, but as an invitation, not as a weight, but as a wonder. Let it transform your relationship with ordinary moments, with daily experiences, with the simple fact of existence. Because in the simplest act of awareness, in the most basic moment of consciousness, in the fundamental fact of experience, you encounter the edge of reality, the boundary where existence meets itself, where the cosmos experiences its own nature, where being becomes aware of being. And that, perhaps, is both the greatest mystery and the deepest joy. That in your ordinary, everyday consciousness, you participate in something extraordinary. The universe waking up to itself, reality recognizing its own nature, existence contemplating its own miraculous being. Not as something separate from your daily life, but as the very essence of it. Not as an abstract concept, but as a lived experience. Not as a distant truth, but as an immediate reality. The cosmos isn't just out there in the distant stars, but in here, in the awareness reading these words, in the consciousness pondering these mysteries, in the experience encountering these ideas. The edge of reality isn't just at the cosmic horizon, but at the boundary of perception, at the frontier of comprehension, at the limit of understanding. And perhaps that's why we feel such wonder when we gaze at the night sky, such awe when we contemplate the cosmic vastness, such reverence when we consider the mystery of existence. Because in those moments, we recognize, not intellectually but experientially, our profound connection to the whole, our intimate relationship with the cosmic process, our fundamental identity with the mystery of being itself. So, I invite you to cultivate these moments of wonder, these experiences of awe, these recognitions of reverence, not as escapes from ordinary life, but as entrances into its depths, not as departures from reality, but as immersions in its mystery, not as transcendences of existence, but as embodiments of its wonder. Look up at the night sky and allow yourself to feel both your insignificance in the cosmic scale and your significance as a conscious participant in the universe's self-awareness. Contemplate the atoms that compose your body and recognize both their ancient cosmic origins and their temporary configuration as the particular being you currently are. Consider the consciousness that allows you to read these words and acknowledge both its evolutionary history and its present miracle. In these contemplations, these recognitions, these awarenesses, you participate in the cosmos's self-understanding, in reality's self-reflection, in existence's self-revelation, not as something separate from your daily life, but as the very essence of it, not as an abstract concept, but as a lived experience, not as a distant truth, but as an immediate reality. And perhaps that's the deepest insight of all, that the edge of reality isn't somewhere else, in some distant cosmic realm or microscopic quantum domain, but here, now, in the ordinary fact of experience, in the simple miracle of awareness, in the astonishing reality of being at all. So, as our journey together concludes, as our exploration of cosmic mysteries reaches its end, I leave you with this final thought. The universe may be infinite, but so is the depth of your consciousness. Reality may have no edge, but neither does the wonder of being. Existence may be boundless, but so is the mystery of awareness. You stand at the frontier of the known, at the boundary of understanding, at the edge of comprehension. Not because you've reached the limits of reality, but because you are reality exploring its own limitlessness, the cosmos investigating its own infinitude, existence contemplating its own boundlessness. And in that exploration, that investigation, that contemplation, you participate in the greatest adventure of all. The universe waking up to itself, reality recognizing its own nature, existence marveling at its own miraculous being. The edge of reality isn't out there waiting to be found. It's here, now, in the awareness reading these words, in the consciousness pondering these mysteries, in the experience encountering these ideas. You don't need to reach the edge of the universe to find the edge of reality. You are that edge, the boundary where existence meets itself, where the cosmos experiences its own nature, where being becomes aware of being. And that, perhaps, is the most profound mystery of all. Not that the universe exists, but that it exists as you. Not that reality is, but that it is as this particular awareness, this specific consciousness, this unique experience. The cosmos may be vast, but your consciousness contains it. Reality may be boundless, but your awareness encompasses it. Existence may be infinite, but your experience embodies it. Not because you're separate from the cosmic process, but because you're an expression of it. Not because you're distinct from reality, but because you're a manifestation of it. Not because you're outside of existence, but because you're a unique configuration of it. And so, as we part ways on this cosmic journey, as our exploration of the edge of reality comes to a close, remember this. The universe has no boundary, but consciousness has no limit. Reality has no edge, but awareness has no end. Existence has no border, but experience has no bound. You don't need to find the edge of reality. You are the edge, the frontier where existence meets itself, where the cosmos experiences its own nature, where being becomes aware of being. And in that awareness, that experience, that being, you participate in the infinite unfolding of reality, in the boundless creativity of existence, in the limitless wonder of consciousness itself. The universe has no edge, and neither do you.